Yes. Did we finish the big O notation? Yes. I think we do logarithmic complexity. Oh, I didn't. Okay, the reason why I don't want to talk about it is because I think logarithmic complexity is like it will. I'll showcase when we do the binary search, because when we do the binary search, we'll understand why, because an example of the O log n is a binary search, and we are going to do it just right now after we do linear search. So we'll see it. Why is it referred to as O log n complexity? Yeah. Okay. That's why I didn't want to talk about it. Okay. Okay.
Yeah, Linda, I've started the recording.
Yes.
And also yesterday after the session, I went and researched, or I maybe did a study on the Fibonacci thing. So in case people have issues on that, I can be of help on that. However, if there's no problem there, I think we can start away with the searching.
Okay, and can I think you can, if there are people who still have the problem, you can do a recap, then we go ahead.
Okay, I don't know if people have issues or are they understood.
Me, I still don't understand how we got 8 and 5. So,
yes. So I think let me stop sharing so that you can do a recap on it. Then we go ahead.
Mm-hmm.
Oh, okay.
I tried your method, Lisa.
Yes.
And I added the ones and they were coming to 5. So, still confused.
Okay.
I got how you explained it and I was able to understand up to there, but I can't still understand how it came to 8.
Okay.
Why it was coming to 8 and why it was coming to 5 when you do it manually.
Okay. So let's look at what Nehemiah will do, and let everybody just engage, ask questions. The more you engage, the more the lesson becomes interesting.
That's true. Because sometimes you can think that you know something, and then to realize that there's a better way not to do something. So the input from the members is also always good, and also it shows that you have people following. So okay, here let me open the. I think the person who is talking can mute, so that's unless it is meant for us. I didn't even ask if you're able to hear me. Sometimes I usually find this thing like it drops the sounds. You can see like now. It usually I don't know what it is always the problem. But you can hear me.
Yes, now we can hear you. Thank you.
Yes.
And also I think I've shared the screen. You're able to see also the screen.
Yes.
Okay. Yeah, so essentially, the aspect of a recursion, if I can begin, or maybe Linda will talk more about recursion later in the Lambda. I heard her saying that, but maybe if to go direct to the Fibonacci thing. So essentially, where I read, it says that the Fibonacci is like a sequence where two preceding preceding the values before, right? You know, I'm not good in English. So the the two values before the current values, they sum up to like they are the determinants of the next value. So like it usually begin with 0 and 1. So the Fibonacci sequence begin from, let me just type there, Fibonacci, Fibonacci. Is it Fibonacci? Let me say it begins with 0 and 1. So it begins with 0, and let me make it a markdown. Are you able to see these letters? The words well?
Yes.
Yeah, so basically the Fibonacci is a sequence of numbers where the preceding two values determine the next values. It determines the next two values, and it begins from with these two values, 0 and 1. I don't know if guys you can hear the backgrounds. The background noise. I think today is Saturday. People, children are not going to school, so there's a lot of noise here. I don't know if it's affecting you guys, or I'll look for a better location.
Sounds alright.
It's not that much.
It's okay.
All right, thank you, and sorry so much for that. Sorry. So essentially, the Fibonacci, it begins with these two values, 0 and 1. And so if you want to determine the next value, you'll do two preceding values like a 0 plus 1, and then it will determine the next value, which will be 1. So again, if you want to find the next value in this Fibonacci sequence or a series, you'll do again 1 plus 1, and then you'll get 2. So if you want to find the next one, you'll do the 1 plus 2, then you'll find it is 3. So the next one, it will be 2 plus 3, 2 plus 3, that will be 5, and let me use this ellipse to show that it goes to infinity that way. Now in the function in the code approach, let's try to define something. I'll just use a very simple example. I don't want to make it complicated, so let me just call it define a function, and then can I call it fib or whichever name that's pleasing, and I'll use n, for instance. You know, like, but remember, it is very important to be descriptive. So I'll add in the codes here, the code. So the first one, because we say that the values begin from 0 and 1, so we need to to determine the the determinator or the base, so that we may prevent the system from going to infinity. Remember, now when you are working in Python, it's not something that is predefined. You have to set it on yourself, to write a program on yourself that's going to do that is going to do the Fibonacci, and that we understand based on their explanation or a definition of Fibonacci is a sequence where two preceding values determines the next value in the series. So essentially, it's you to set it. So the base is, you can say, for example, the base, you can set it to 1. Or I saw someone yesterday using maybe did this, I think, and set it to 1. So essentially it's just the same. Remember, 0, when you add 0 plus 1 is the same as 1. So when you use 1, there's no problem. And you can add in a condition. For example, when the condition is met, it can execute something there. So so here you can say, for example, when it is 1, you can say return something else. Like for example, let's say the Fibonacci ends. Fibonacci ends, or whichever thing that is so pleasing to you. Now, the next thing is now to define your now to define your recursion. You know, your the recursion that will define the Fibonacci, because it's a program that we are going to define it ourselves, or we are going to create it ourselves. So if it's not made, we can do the else, so that it can perform another operation. So if it's above 1, we can return now. So recursion is a process where a function can call itself. It can call itself, and I think Linda shall describe it well later. But this is just a sneak peek about what she's going to share with us. However, so because based on the definition of the Fibonacci, it says that the two preceding values determines the next value, right? So, for example, if you want to do the recursion to determine that, so you'll call the same function, which is I'll use a fib because that's the function definition that I used, and then now, so the first value that we are going to determine is just the next value before the current value. So assuming that our value is 3. So what is going to determine the next value? It is the previous value, just a value just a value before these 3, of which is going to be 2. And then another thing is going to be a value 2 steps. For this 3 is going to be 2 steps. That will be 1. So when you add in 1 plus 2, it's going to give you the next 3. So this is why you can use, for example, n minus 1. So to determine the next, or the value just adjacent, or just before the number, just before the number. And then, so assuming that for example, assuming that we are using 3, so the next number, or the number, it will be 2. But let me try to do this. Let me call it so that let me just use fib, and I give it a value so that I can use a value let me use a 5. Yesterday we used 5. Let me use 5. So now in this context, it's going to find the Fibonacci. When you use n minus 1, it's going to determine the number before it in the Fibonacci sequence, of which, for example, if you are, let me use I think here there's a mistake. It should have been 5, and so forth. So, for example, if you're looking for this Fibonacci of 5, so in this Fibonacci sequence, it's going to look for the number just before that 5. That's why we are using n minus 1. And then because we say that the Fibonacci thing sums with 2 preceding numbers, I don't know if I'm using the correct word, preceding or something, but it is this number, and then again 2 steps behind, or 2 steps backward. So it's going to be this number. So you'll subtract 2 two steps, so that when you add in, for example, these 2 and then a 3, you're going to determine the next value. So that's why she did this. You add those values. So it was like a fib, and then now, because now you are targeting, for example, the other value is going to be n now minus 2. So basically the number that you will return, that will be the Fibonacci that you are looking. I don't know if you guys are understanding what essentially this thing is doing. So basically, essentially, let me try to run. Sorry, invalid syntax. So I should have done what I should have. You guys should have told me. I should have used if n is if n is less than or equal to, is this condition? Let me try to run first of all and see. Fibonacci ends. Now, is my code really? Where is the problem here, guys? You can tell me.
You should
Or let me use one. Let me just equate to pardon?
It should return n.
It should return n. You have told it should return Fibonacci n. Ama?
Oh, the Fibonacci of n.
As in, there return where you've written Fibonacci n. That's why I saw they just say return n.
Oh,
like return the number. Like return, if it is equal to 1, return the number like 1.
Oh, essentially on this return, you can basically return anything. You can return it. This it doesn't like, it's not like a big, you know, you can just do something there so that you can display something at the, you know, at the output.
When it's working, it's returning 5.
Yeah, so essentially this is like how it's done. I don't know if people have but I think
the problem yesterday is when we were returning 8, people were getting 8 and 5. We were trying to explain why it's supposed to return 8, not 5. I think that is where some of myself, like, I got lost.
Also, this code that I've written here, I don't know. I don't think if it's correct. I think there's an error somewhere. If people can try to like look on it and
when you say,
it should return 5. It should return 5.
Jolene, when we say Fibonacci, I think my problem is when we say Fibonacci 5. What are we supposed to return? The 5th number, the 5th index, or we are returning the 6th number?
So you see, in the Fibonacci series, you don't start counting from the 0. You start counting from 1, right?
1.
And I was telling you this method. Let's say you don't know what a Fibonacci series looks like. So in this case, maybe now you know there is 0, 1, 1, 2, 3, 5, right? So you want to return the next number. Sasa si unaanza kukauntia hapa kwa 1, 1, 2, 3, 4, 5. So this 5 is Fibonacci 5. So if Nehemiah, you change here, you write return this fib down here, write 6, you see, it will return 8.
It will return 8.
Yes. Like basically the position. If you run it, Nehemiah, it will return 8.
Hapana, eka 6.
Umeruka. Sorry.
That is now from Python, sindio?
Yeah, so you can put 5, 8. If you want the 7th number, you put here fib 7. It will return 8 plus 5. It will return 13. If you want the 7th one, you can put 7 here. It will return 21. So it will be 8 plus 13. So you're just generating the Fibonacci series. That's what I was saying with the deck.
Using the Python. But if you are using manually, the answer would be different. Sindio?
If you're using manually, still the same. See, 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 5 is 13.
So for all Fibonacci sequences, whether manually or whatever, we start from 1. Yes. Thank you. Now I've understood. If you say that, me, I was doing my own things. Okay, thank you. I've understood. Thank you so much.
Literally, it begins from 0, but we assume 0 because when you add 0 plus 1, it's just 1. It's just 1. So, but when you are defining...
Actually, Nehemiah, you can say 0 and 1 are constant. We have Fibonacci, 0 and 1 were constant. So that's why we start from there.
Sure. Yeah, so Linda, this is what I wanted to share with the people based on what I had read. So
thank you so much.
Thank you for clarifying. Thank you so much. Hey, thank you.
Yeah.
So I think we'll just go ahead to search. So as I was telling you, the reason as to why I've skipped talking about the or is it the logarithm, the one Lorraine has asked, is because if even you check on the Explore AI, the example that they used was a binary search. So I didn't want to talk about it, and we are going to talk about it like the binary search, so that you cannot, it falls under the big O notation of n log O. So under searching, we know that if you search for something, like you're going to look for something like a pen, or you're going to look for something like it's just like determining if that something is present in what you're looking for. For example, if you have cups and all of them are different colors, maybe you're looking for one color which is red among those cups. So that is basically what searching is. So we always need to determine if a particular character, string, or number is present within a data structure. So definitely the Python has always provided us with inbuilt functions that can help us to determine if a string contains the such string. So definitely there are the regets or something like find. Those are the inbuilt functions that Python has. But for us, we will go the longer way. You need to understand how are you searching this particular string in a particular string in that the string you are searching about, or a particular number in a list, or a particular number in an array. But if you use the inbuilt function, you can just write the list and then you write find this and this, like the way Nehemiah had taught us earlier when we were doing the first steps. You remember, like even sorting, like when he wanted to sort numbers, he was using an inbuilt function called sort. So that is the same as searching. You can use an inbuilt function called find, but now we want to understand more. How are you going to find this particular number in that list or array or search string? I hope I hope you have understood up to there. So the first one is we want to start with the linear search. The linear. So definitely the linear search, it searches for a value by looking through each element of the search. So let's say you have numbers. You'll consider the number that you want to look for. For example, let me just, I hope today this screen will write because these things need to be practical. So let's say maybe we have 10, then we have 14, then we have 19. Is it looking okay?
It's okay.
Okay, so we have 26, we have 27, we have 31, then we have 35, and then let me stop at, let's say, 42. So this is, let's say, our list. And remember, we know the index of each one of them. So let me do this. Okay, I hope by this everybody is seeing. So for linear search, most of the time, you want to return the index, like you return the index, the location of that particular element that you are looking for in that list, or that particular number that you're looking for in that list. So let's say, for example, here we want to look for, let's say maybe our value that we are searching for, or the search value or the key value we want to look for is 31. You see? So we want to look for 31 in this list, or an array, whichever your string will be. So you will iterate through the list one by one as you go by. For example, the first iteration, you will compare your value with the first index. So for example, you will compare 31 to 10. Then if you check, is 10 equals to 31? Is it the number you are looking for? Then you realize it's not. So you cancel. Then you go to the second iteration. You are iterating through this list. You go, the next one is 14. Is 14 equals to 31? No. You go ahead. You go to the third iteration. It searches. Is 19 equals to 31? No. You go ahead. Is
26 equals to 31? No. You move to this is the fourth, so you move to the fifth iteration. The fifth iteration is 27, which is not equals to 31. Then you go to 6, you get 31 is equals to 31. This is the sixth iteration. So at index 0, it was not the same, and index 1 is not the same, index 2 is not the same, index 3 is not the same, index 4 is not the same, but you get index 5 it's that one. So you stop there and return the index of that element. So that is what we call bilinear search. So after you've understood this, now you can implement it in the Python code, how you can go about it. So basically you are just looking at a list, then that list you have your value. Like you have your value in mind that you're looking for, even if it could be 42 or 35. You know, in this list, you want to search for the index number of 35. So definitely you'll go through index 0, 1, 2, 3, 4, 5. Then when you reach at index 6, you realize that is the 35 number you are looking for. You stop and return the index number. So who has not understood from there before we implement? Any question? Are you people okay with like the way I've explained? Okay, thank you so much. So let's go and implement now the code. So we can define, let's say linear. So under arguments, you are taking that list. Is it a list or an array or any? Is it a tuple or something? So for example, let's call ours my list. Then you have to bring in the next argument, which is the target, or somebody can say the key value, or you can say the search value, like anything you want to use, there's no problem. So you have your list. This is the list. Those are the numbers you have, the one that I've shown you. Then the search value is that value that you want to look for in this list that you want to work on it. So we go ahead and bring in now the reasoning. We've seen that we are going on that list, then we are iterating. So when we are iterating, it's either you can use somebody can decide to use the for loop or the while loop, but you can use the for loop so that you can iterate through that list. So let's say for I, remember I is just a variable. You can say then for Peter, for something, for Linda, anything. So let's say in the range of that now our list. But remember our list has a length. And the length for this list, for example, can somebody tell me the length of this list? This one? Just one random person. What is the length?
I think that length, it has 8 elements. Let me be sure.
Yes, it's 8.
Yeah.
So you have to make sure that the list, you make sure that when you are iterating, this iteration goes through the entire length of the list. Now it will go from 0, 1, 2, 3, 4, 5, 6, 7. That is in Python, but in real sense, we know the length of the list is 8. But in Python, we usually start count from 0. So you'll say length. Length, then my list. If I confuse somewhere, you let me know. Is that okay? I think I need to place here a bracket. Yeah, so like that. So I want you to see, you have a list. You are iterating through that list one by one so that you can get that element that you want. You see, so you ask yourself, what happens? You put a condition such that in case if that's, so in my list, that element that you've gotten is equals to the value that you are looking for now, to the value that you are looking for. You see, you return. I think I need to, you return the index of that value, or you can say return true or return something else. You can return, maybe you can say not found or false. Let's say not found. Okay, up to there, who has not understood? I hope my code doesn't have any problem. Anyone who is not understanding up to here, like the way I've explained, then now we are doing it. Now I've shown you physically what is happening. Now you are taking what you've been doing physically, you are bringing it in the code. You have your list here, you have your search value. You iterate through that list, then you put a condition. When you get the value that you're looking for in your list is equals to the search value that you want, you return the index of that. Or else return not found, meaning that value is not in that list. So that means if it's not found, it can go back and iterate, and it goes ahead up to the end, maybe where you didn't stop, so that it goes on searching, and that will be, you realize that it becomes a tedious problem, and the complexity, now the term complexity becomes big, like it's a worst case scenario. So let's try and test it. Let me run first this. I know if the code is good. Yeah, it's good.
Linda,
Yes?
what's the purpose of the range? The second line for
The range is it's ranging from the first value to the last value. Like it's looking for that length, for the length of the list. So range basically means, let's say it's ranging from here to here. So it's iterating in this range. They range from 10 to 42.
Okay.
Yeah. So basically we can try like an example. Let's say we have my list, then is equals to let's say we have 1, 3, let me just guess, 6, 7, 9, 10, 11. Then we can say our search, value. Can we say let's say we are looking for 9, right? So we can print. Now let me call the function limit. If you see my spelling star, then you help me. I'm always bad at typing. Is everything okay? My list, search value. It will take time to load. It needs to be linear because I'm calling the function. Can you help me know where the problem is, please? Anyone?
Hey, can you go to yeah, there. Let me see.
My problem is here. I know what is happening. Yeah. It should be returned it should be this one and this one. So let's see. Yeah, that worked. The problem was here, like I was not supposed to use the how do we call this? Because we are looking for the index of each and every element in that list. So I cannot say my list and then I use these ones, these is it, how are they called?
Round bracket.
Yeah, round brackets. Use the block brackets. This one. That's why it was not working. But definitely you can see. So our target value is 9. Then print linear my list search value. I think it should return the index of that. It should return 0, 1, 2, 3, 4, 5. It should return 5, not found.
The reason why it's returning not found is that in your if function, you are asking for that index, the I index.
Yes.
Right?
Yes.
And you are equating it to the search value.
Yes.
Can you try to change like because you've defined that I, like I would say that I is like a variable. So
yes,
instead you can use the I itself there at the bottom. You can just use there at the bottom in the if. So if
yes, that's what I'm saying.
Yes, so that part of the if, instead of that, because already that my list, you replace it with a variable. So the variable, the container is gonna be I.
So like that, if I is equals to such value.
Yes, yes.
Yes.
So and then run the bottom one. Again. The bottom one.
We run the bottom one.
Not yet.
Wait.
We shouldn't say I is equals to 9. Mama?
It should say I is equals to, because it's picking the index of the 0, 1, 2, 3, 4, 5. It should return 9. Because we are searching for the value 9, so it should return the index of that 9. And this, it's just a code that I've written from, like I've just written from our reasoning.
I think we need to look at the second statement in the first code for I in range, length my list. I think that might be where our issue is, the second and the third, because we need it to look for 9, and then we are asking it to look at the length, or should we have the length and the range together?
Okay, let me do
of the list.
Yeah, by the way.
Like that?
You can like the length function.
What if down there you write I is equals to 9, my list I is equal to 9.
Where? My list where?
There, what if you write, instead of such value, you say I is equal to 9.
Okay.
Just thinking out loud, not that I'm sure.
Yeah, coding is trial and error till we get it. Still, it's
no, there's a reason you can't put I is equal to 9, because you are saying that your search input, you are giving the value of your search input, right?
Yes.
So, yes. Enumerate also works like that too, but we can also use this method. This define, yes, is correct. For I in the range of the length of, yes, you should check through the index true. If
I think the code that you've written here,
yes,
it's not like. So let's try to like understand your code first of all.
Okay.
You see the second line here you've said for I in the range. So basically the range is gonna define the range of which your search operation is going to occur. But now when you use now that length function, remember now the length is going to like determine the number of elements in your list.
In the list,
so
yes.
it's gonna like it's trying to like find if your list has 9 elements in it. It's not searching for a specific value. Whenever you have that length, it's going to convert your list so that it returns and the number of elements. Remember the length operator, the length function only
Yes.
returns the the number, the length of elements in your list. So
Yes.
essentially it should return not found, because when you do a
Yes.
count on your list, if it's not 9, if it's not like a 9, then of course it has to like return the error.
Yes.
So I think the issue is with that code there, with the length function there.
I agree, because it will count. So, and the elements are not there. How many? 1, 2, 3, 4, 5, 6, 7. So that's why it keeps saying not found, because it's looking for 9 elements and it's not finding 9 elements.
So I just say for range in my list.
Enumerate or for range.
Okay.
The reason if you do that, is because you are saying that you are very sure that your list is an integer. If she adds cat to that list, she will need to first convert it to integer, because that range length converts the list to integers. So what I think is that exactly that place, that code, what she just did now.
I think the code had no issue.
And then also, you can't use arrange. Arrange is whenever you use any method or a built-in function in Python, it should be inside the parentheses. So you can't use the range that way. They are
you can't use the range that way. You can't use the range that way.
Yeah.
Put the length back. So I think
The way it was.
the bottom code.
Yeah.
No, there's a zero there.
By the way, can you just try like explain before you even run what your code is doing?
Yeah.
You can try to like explain first of all, because you need to understand first of all the code.
Yes.
Yeah.
So definitely the code, it has two arguments. We have the list, my list that we have, and we have the search value that now we have, maybe we have said this is the value that we want to get from this. So definitely we iterate through the list to look for that value. And that's why now we are coming in, we are saying for I in now the range of the length of that list. So here is the length, that is, it's looking at the number of elements in that list. And when we say length my list, it is giving us the length of that list that we want to look for that number. Then range now comes in, whereby it's always an inbuilt function, but it comes in because it's generating a sequence from 0 to n-1, because now the length of my list usually let's say 9, but because Python starts from index 0, our length becomes n-1. So in this case, it generates the sequence number from index 0 to index 8, let's say, if our element was like that. So when we say for I in range length my list, the for loop iterates over that variable, which is I, in every element of the list. Then the sequence of numbers are generated on the range of the length of our list. So that means that if the iteration works, I takes on the values, let's say it starts with 0, then it goes to 1, then it goes to 2, all the way. If our list was going up to 9, the last one will be n-1, which is 8. So that is basically what this part is doing. Then the next part is saying if my list now that for I is equals to such value, then it returns that index. You see, else it should return not found. But you see now for us, if it's saying not found, that is wrong, because our 9 it's in this. Because if we could have said maybe 13, then it should say not found, because indeed 13 is not on our list. You see now this is true. But if we say 9, it should give us the index. So from there, I
Can you
think that is
try?
what the
Can you
problem
try
is.
put a search value in index 9? Let's say 0, 1, 2, 3. Search value is equal to 6, and you run VC.
Here,
Yeah, search value is equal to 6.
not found, but you see
Now,
it's there.
first of all, what's the problem? What are we trying? Are we trying to find the index of the element, or are we trying to we are trying to search the index of the element that we are looking at? Oh,
Yes, yes.
oh, okay, okay. Thank you.
And I didn't want to use the
Hello,
enumerator.
so we are looking for index, not the number 9.
Yes.
The whole time, because number 9 we wouldn't have needed in range and length, which I've just said for I in my list.
Exactly.
If that one is equal to that one. Okay.
Yeah.
Okay. I think we need to initialize index or something like that. Like say index is equals to 0, and then we keep saying index plus or minus 1. Although I think that range and length should return. But there is a way you can do it by saying, so you define it, and you say for I in my list, if I equals to now the search value, then you return either the index, which we initialized at first. So it shouldn't be returning I, it should be returning index. But that's when we don't have now the range and length. I think that's a different way.
And then
That
also,
should give you an answer.
and then also, you see that place where you have the if and then my list. So essentially, whenever you use a for loop, or whenever you are saying, for example, that part of the I, it means
Yes.
that you are creating another variable instead of that part of my list. So in the next line, you can't use the same variable because you're using the previous variable to be like a value for this I. So when you say for I and then in range of this value, the length that you've defined there. So in the next line, you could have used, for example, I for if I, yeah. So because now that if I is gonna be like the variable of the above iteration. So and then now, for example, if you want to use that square brackets, for example, if you are specifically trying to look for a particular element, you could have done that. But now in this context, for example, if you are saying if I is such a search value, I think it should be okay. You can return.
Return index.
So you can return something. You can say something like maybe let's say
true.
Something like that. Yeah.
But you see 6 is there. Let's just use the numerator because it works the same so that I thought this one was the easiest because I was just writing from the head.
This one is actually the easiest.
Yeah, it's the easiest, but now it's not working.
Okay. Let's just write that code again together.
Yeah.
Now, so first of all, let's understand the difference between the enumerate and return it that way. Now, when you use the enumerate, it's gonna return the index number and the value.
Yes.
So
Yes.
so basically that's the essence of the enumerate. Unless you want to show us that way.
No,
then,
the enumerate.
No, let's just use length
handles
and
that
range.
function.
Yeah, I think our
Let's
flow
use
is
that
just
letter.
good, but there is something that is I don't know why.
Okay.
Because I think
Let's just write this code again together. Let's write it again together. Then
we are writing from the way we understood from what you explained while I was doing.
Yes.
So we are writing it from the head. So we are defining a function. Then we have our list. Then we have our search value. So from there we are okay, right?
And then also you
For
can
I in range.
Okay. For
Then we
I in
iterate.
range.
Thank you. So for I in sorry.
You are writing the book.
In
For I in range. Length. Brackets.
Length my
list.
Now this time will be list because I've called it list. Right?
Okay, you've changed it.
Yes.
you
But don't be using list because
you can't use a preserved keyword
you
in
can't use list.
Okay.
Use my list.
Yes.
Go and change it. Is a built-in function.
Oh, yeah.
Okay. My list.
So up to there was okay.
Yes.
Then then after iterating,
If
you
my
need now to
underscore list I,
If my list. No, like
then
the square
index
bracket
I.
index I, yes.
like that.
Yes. Equals set value.
First equals to search value.
Double equals to set value.
Search value is small letters.
Thank you.
Small letter. Yeah.
Okay, sorry to interrupt you guys. Before you go any further, can you like I want to understand that part where you have the if and then my list and then I. Can you try to explain to me what that means?
Because we want to pick the index of that element from the list. So if this iteration goes through that list, then it reaches to an index whereby that index of that number in the list is equal to the search value that we are looking for. Then it returns true because we've ended, like our search has been successful. Yeah.
I've never seen the search, but let's see the output, then we shall explain the part.
Okay. So from there we return. Can you return true?
We can return true, yes.
I think return I.
Okay. Else?
Return not found.
I say false.
No, the else is not in the right place of the indentation.
This should be on the outer loop.
Under the for loop.
Yeah, I think that was the problem now. You are right. Yes.
Exactly.
You are very right. I think that is the problem.
I think that's where the problem is
And I knew, let's now try. Then here we have, let me see if I can undo. So let's run and see now if it will work. No, here we have to be.
How does it?
Yes, it has worked.
It has worked, does it? Oh.
Yeah, it has worked. The problem was this one was executing the inner loop instead of the outer loop. Yeah, it has worked.
Yeah, I agree.
Yeah. There is a person who said hi, guys. Maybe he can talk, but we are now good, okay? The problem was here. Like we are not, the problem with code, you always don't see the problem. You can even stay for 1 hour looking for that problem and it's just easy, like that's something. So we were returning the inner loop, like else return for, so it was working in the inner loop instead of going back to work on the outer loop, because if it iterates and it finds that value is not there, it should return return false. But if let's try. Let's say maybe we have.
Linda, your
Yes.
code is not correct, because you can't use a for and then a else. These are conditional statements. You can only apply if and else. You can't use a for and then a else. You can't use for and else. You say that if, else, and such stuff.
Okay.
No, don't delete. But you can, the problem that I'm trying to see here is that part of the my list. Can you try it like using the I instead, my underscore list?
Okay.
Then just remove that part where we have the if, and then you'll use I instead. It's just correct the way it was written. Yeah, that part.
So I.
Or what you do to make it simple, can you delete from I downward? Yeah, just delete from that part, and then go the other side, and then create a block of code, a line break there. Yeah, and then just say, for example, If you want to use now the if, let's say if I if I is target search, is it search value, search underscore value, and then we can do it. You can return something else. You can just do anything. Say return something like,
let's say true.
Yeah, and then once it's not in, you can do now the else. Yeah. So this one will make sense. So, and then remember, it shouldn't return the numbers. It shouldn't return because now the determinants here we are using true or false. So
Yeah.
it shouldn't return like a true and such number. So I
So
think
if it's 4, it needs to be true because 4 is there. You
Yes,
see?
yes.
But it's still returning false. Can somebody try running on their how is it called?
The problem is the indentation.
The problem is the indentation. Either you put the else at that for place, or you just remove the else and put return true under the for loop. That's when it will be correct.
So I can do this.
It's true because what it does if you don't put that else under the for loop or put the return near the for loop, then what it does, it checks is if I is equals to the search value. So it will check the first thing, it will check the 1. And then when it finds it's not equal, it will just now return what we had there.
Yeah.
And then that's it. It won't go again. But now, if we put it out there, it means it keeps now going to see whether it will find.
Yeah, true. Because yeah, you are right. Because if it gets its false, it will go back to iterate again until it gets that number we are looking for. Yeah, you are right. So we've gotten rid of the else, and it's now working okay. Unless somebody wants to say we need this return false need to be under the if here, which will not work.
No, just this time. Let's just, instead of returning true, let's return I, or let's return search value, whichever the case.
Yes.
So it will perfectly. Yeah.
And now this one will just return the number that you are looking for. This will not return the index. You should know that, because you just say if I is equals to, if that I that you're looking for, like that number is equals to such value, return that number. So it's not the index. So if you say it's 11, still you'll get 11. Is it 11? Sorry. Oh my God. This is terrible. Why is it returning 4, and if I put 11, it's not returning 11?
Have you run the second code after
Yes.
11?
Yes. Let's try. Okay, let me try 7.
I know where the problem is.
Yes.
So essentially, this is like when you use now that return, you are like, when you use that return at that indentation level or at that indentation level, you are assuming everything in that for loop for things. So it's going like you are defining a function there, right? But
Yes.
you just want to return the way you can just say print hello world. You're just saying return false. So it's going to return false, or when you write there true, it's going to return true. It's going to ignore everything that is in this block of code here that you've done the iteration there. So there's no operation that is going to work there. It's just returning the false. Whenever you use the return statement in the same indentation block or at the block level with that for loop, it's going to ignore everything that's above there.
Okay.
So a good operation.
Why did you remove my list I Because that's
Because my list I we were looking at the index. We were looking at
okay.
if it gets the index.
But if you want to get the number, you don't even need to look at the range and the length. You just, if
Exactly.
I in my list, if I,
Yeah.
you won't use the same formula, rather code.
Yeah, like comparison.
But
That's true. That's true.
but that's only if the list is an integer. If the list contains string, you will still need to use this range my list to first convert it to index so that you can use the index to search for the particular element you are looking for. So you are only saying that you can you do the run the code directly because you know everything is an integer. So naturally, we should get used to converting it to using range len because you never can tell what is in the list. It could be more than, it could be more or more, what do you call it? Different data types than you think, you know. So
Yeah, this works because we are looking at the index. But if you say I is equals to such value, you are looking for, we are searching for that value. Because if you understood, we said if you are doing linear search, you are iterating over the list, then you are returning the index of the first occurrence of the searched element when it's found. So that means the for loop goes through the range of our list, then it looks for it searches for the index, like it's looking each index of that element. Like for example here, it looks for, I was even to speak Swahili. It looks for index, like it's looking for the index. So it's looking an index where that value is the same as the value we are looking for. And when it's found, then that means our search is successful.
yes,
Then
exactly.
another thing is that even if we had here 31, and let's say we have another 31 here, it will just return the index of the first 31. It ignores the occurrence of the other one, because that one is not, it's not always considered. And I didn't want to use the reason why I didn't want to use the enumerate. I didn't want maybe to confuse people. I wanted, like, we write from scratch, we see what is happening, like somebody knows you are searching linearly, what are you doing? That is why I decided maybe we just write from scratch. Yeah, I didn't want to use enumerate to start asking what does it mean, what does it do. But another person can use the enumerate method, so long as we are heading on we are getting the same answer. Yeah.
And then
So are we okay?
We are okay. It's fine. It's fine. Though that part is like you are trying to repeat to yourself. You see that part where you can go to your code. You can see that part where you have my list. You know, like whenever you use a for and then you say I, it's like it's going to be a container of that my list. So you don't have to repeat my list again. So instead of my list, you can just use that I itself.
But it being blocks like that.
And then you use I instead of the code, what I call the square bracket, just I.
So if we do that, we'll not get the answer. It's not giving us.
Just
okay, because that we had done that. So let's see. You see, it says 7 is false, and you see 7 is indeed in this list. It's there. So you are. I think this condition for if my list, it's looking if an index in that list, because we are looking at the index of that number that we're looking for. But you see here even if I place 11 is in this list, but if I run it, it will tell me it's false. But you see, it should tell me it's true.
Can you try to do like? Can you try to do?
Yes.
To do just add there one.
Where?
Just the search value to be something like 1.
Here.
There the search value.
Here or here.
The search value variable.
Here.
At the bottom there. The
This
value.
one,
yeah. Give it
1.
Give it or 2. 2. Just use for example something
2.
Like that. Yeah.
You
Yeah,
see?
so basically my assumption in this condition, I'm
Yes.
assuming that you are doing what you let me try to see first of all. So like I'm assuming that you are looking for a particular particular index.
Yes.
Though I don't know how to explain it well, but whichever ways that the people understand, I think it's better.
Okay, is there anybody who is lagging behind? We want to be, everybody should be on the same page. Anyone? Okay.
I'm not on the same page, but I'll watch later.
Okay. Or if somebody goes and understands it more, you can come in and explain to us more. But this is, for me, this is how I understood it the first time. And the only problem that I had is that the return false, I was placing it inside the, here, after the if, then so it was doing if my list, then else do this. That's why it was not giving us the answer. So let's go to binary search. So this one I know we will stay here. That's no problem. Okay, so for binary search, okay, there is something I want also to tell you. For linear search, it doesn't matter whether the list is sorted or not sorted, because you are only looking for one value in that. Even if it was mangoes, potatoes, bananas, something, if you are looking for that value mangoes, you'll just get the mangoes you're looking for, because it's only one in that. And it's not like it doesn't work on sorted lists. So no matter how the list is arranged, you can do it. But for binary search, you have, like, the list should be sorted. The list should be sorted for it to work in ascending order. So in short, binary search algorithm, it finds the position of the value that you are searching for within a sorted array or a list. So the condition here is that the list or the array must always be sorted in ascending order. So I think I'll just come here so that we can do it practically. So under binary search, you must know that the condition is that make sure that you are starting from the low end to the high end, or somebody can say he's starting from the start to the end, or another person can say, like the way, let me write down so that let's say we have 10, 14, 19, 26, 27, 31, 33, 35, then let's say 42, then 44. The reason I'm doing this is because I realized that if you don't understand how these things are working, you can't even implement that. You can't implement the algorithm, because at first you don't know even what is happening. You can't just go ahead and write an algorithm and you don't know what you are doing or what is happening from this. So what I mean is that, let's say, let me give them the index. This thing has started now misbehaving, and it was just okay. 3, 4, 5, 6, 7, 8. Then this one is 9. So this is what I'm saying. This is the low end. So this is low. Then this is high. It has certain misbehaving, but I think you just understand. So you need to start. You need to have the low end and the high end. Another person can have the how is it called? Another person can decide to call this the start. This is the end. Or another person can decide to call this is maybe mark. Somebody can even say this is max, mean, max. or anything that you can decide to call it, like the but make sure you have the start point and the end point. So for me, I'll say this is my lowest point and this is my highest point. So under the concept of the binary search is that you need to look at the middle. So let's say you have 42. Let me see if I can just go back to just a minute. Let me go here. Let me clear and see if it will work. It will write very well here. The next one was 31, 33. Then you have 35, 42, 44. So let's say this is our list, or maybe when it's an array. So 26, 27. So that is how it looks. So let me give them the index. 5, 6, 7, 8, 9. So this is my low point and this is my high point. And let's say I'm looking for, let's guess, which value can we look for? Let's say we want to look for 44 because it's at the end, so that you understand well. So let's say my target value is 44, right? So the goal of the binary search is you need to find the mid between these, the mid of this list or this array. So that's why you come and say low, high plus low, divide by 2. Then from there now, you need now to look at that mid. You look at if the value that you're looking for is on the right side or on the, is it on the left side of the list. Let's just do it practically. So let's say this is my low, this is my high, then this is my mid. So how are we going to look for the mid? We look at the index values of this list. So we'll start by the first one. We want to look for the mid of this one. So the first one will be, will give me the first, what will I do the first thing? You can just unmute and tell me, what will be my low value? Anyone?
10.
No. The index. You are right now. Yes. So it will be 0. And then the high will be
9.
So what will be our mid? It is 9 plus 0 by 2. Are you getting what I'm saying? So our mid value, yes. So it will be 4.5, but you cannot take 4.5. So you take the lowest, so it will be 4. So that means our mid value is here. I don't know if you are getting me what I'm trying to say. Anyone who is stuck, we start again. Because I want everybody to be on the same page. Because after that is when you know how to write the algorithm. You'll understand how the algorithm is moving. Okay. So after that, our middle value now is at index 4, which is 27, right? So you check 27. Is 27 less than 44? Or is 27 greater than 44? Remember our target value is this 44. I don't know if I wrote it well. The target value here is 44. So you stand at 27. Then, because you calculated the mid and you got it's 4.5, you take 4, you don't, because you can't round off, you go to 5, you take the leading half. There is a concept, if I remember, I'll tell you why we don't round it off. So 4, then you stand at 27. Then you look at this 27. Then you ask yourself, is 27 greater than 44 or less than 44? So is it less or greater than?
Greater. It's less.
Less.
It's less. So if it's less than, you move to the right and add 1. So let's say if our is it I? If our I now is here, you move ahead and bring it now to the next value here. Now you come and stand here now because 27 is less than 44, so you move to the right. If it could have been maybe a number like 90, you could have moved to the left. Do you get what I'm saying? And so if you move to the right, you always add plus the mid plus 1. So you come and stand now on 31. So when you stand on 31, that will be your low value. So my low value comes here and my high value remains to be 9. So you come back to the table. What is my low value? My low value is 5. What is my highest value? My highest value is 9. Then you add, sorry, it overrate. So you add 9 plus 5. I'm just trying to scribble because if I don't scribble, I don't think. So no matter how the handwriting is, just make sure you are understanding. So 9 plus 5, what is 9 plus 5?
14.
Divide by 2?
7.
So that means, sorry, where is my laptop? Sensitive. So that means here will be 7. Just a minute. It's so sensitive. I don't know what happened. It's not moving. Okay, so I think what I'll just do, I don't know what I'll do now because it's not, just a minute. I think imehanga hapa but haina shida. Let me see if itajitengeneza. And the way it was imeanza kuwa interesting. Oh, sorry for Kiswahili. Where will I write now? Okay, so I think I'll just go ahead and explain for you. So, who can help me understand why my laptop is hanging?
Linda,
Yes, what do I do?
is it possible to just like maybe write it open? Can you go back to where you are writing the codes?
Oh, here.
Yeah.
Oh, so
Can
I
you just write it?
can do it here. Okay, no
Just
problem.
like write it down there.
Because I wanted the, okay, let me sign. Okay, let me do that. Thank you. So let me start again. Oh my God, I'm so sorry, you guys. 19, 26, 27. What was the next one? 31.
33,
31, 33. Then?
35, 42, 44.
Thank you. 42, 44. Okay, so I had told you this is 0. Then 1. The other way was good, but it's okay. Let me just because I wanted you to look at the indexes so that you can understand. So 0, that is 1. This is index 2. This is index 3. This is index 4. This is index 5. This is index 6. This is index 7. This is index 8. Then this is index 9. Right? So from there now, what I'm trying to tell you is that we want to get our target. We are looking for our target value, which is 44, right? So if our target value is 44, because this is like, this list is not sorted. If it's like, it's not, is it it's sorted, but is it sorted 10, 14, 19? Yes, but our 44 value is at the end. So you want to look at this 44 and remember something. Imagine you are doing linear search. You see, you iterate through the first one, the second one, the third one, the fourth one, like you are going. So it takes much time, like your time complexity increases, like it's more time. So if, let's say, you had values 100, like up to 100, it could be hard for you to iterate. You are iterating. That's why now we are coming to binary search. It's making, like, it's simply, although it's not at the best case scenario, but it's simplifying our search. So we look at the mid, and I've told you, for me, I'll take the mid is equals to low plus high, then I'll divide it by 2. So we started with the first one. So our first pass was 0 plus 9, right? Then divide by 2. which you got 4.5. And then I told you we'll stop at 4. So if you stop at 4, we realize that the value at 4 is 27, and 27 is less than 44. Right? So if it's less than, you move to the right because now it's like you're standing here and your eye is at upper, it's here at 27. So you move to the right side. That means that is where our 44 is. But if this could have been bigger value, definitely 44 could be behind. Do you see the reasoning? So that means we'll go to the right. So if you go to the right, you move mid plus 1. You move mid plus 1 step. So you'll come and stand at 31, sorry. So when you stand at 31, now your low value becomes 5 and your high value becomes 9. So you go ahead and say, not 4, this is 5, because we are now here. So you come and say 5 plus 9 divided by 2. There's somebody who gave me the answer. What was the answer?
7.
7. Thank you. So you go and stand at 7. Do you get what I'm saying? So you stand at 7 again. You look at 35. Is 35 greater or less than 44?
Less.
So 35 is less than 44. So that means you move to the right. So that means that when you stood at 7, your eye was at 7, so your I plus 1 will be at 8. Right? So if I plus 1 will be at 8, the next one will be 8 plus 9 divided by 2. That is 17. Is it 17 divided by 2? It is 8.5, so we get 8. Is it right? 8 plus 9 divided by 2?
Yes.
8. Thank you. So you go and stand at 8. So meaning your low value becomes 8 and your high value becomes 9. So did I do the right thing? No. We went and stood at 8 and 9. So the next one will be?
The next will be 9.
So we stand at 9. Then you realize that is the end. Right? So your eye will be here and your high value will still be there. Do you understand it? So because you've moved at 9, so your high value is there and your low value is still your high value is still at 9 and your high value is still at 9. So it becomes 9 plus 9 divided by 2. What do you get? 9. So that means if it reaches 9, it checks now it's 44. Then it gets 44 is equals to 44. So that means the search is successful. So you stop because you've gotten the number. Or else if you will not have gotten it, it continues with the same thing. It continues until you get it. So anybody with that question?
That have been 8 and 9.
Where?
After we said 5 plus 9, then we got 7, then we looked, we said that 35 is less than 44. Then
we move to the right now, you stop here.
Yes. So you won't check 8 and 9.
You will.
Just 9.
I think we skipped.
7.
We skipped it.
Because for the 7 we remained at 35.
At 35, so we moved one step here, right? So it's 8. Yeah, that's right. 8 plus 9 divided by 2. So it gives us
8.5.
8.5. So 8.5, you move ahead. Yeah, that is it. That's true. So you move ahead because you realize 42 is less than 44. So you move one step now to here. Yeah, you're right. Because now here 42 is less than 44. So you move now your eye to the midpoint to plus 1. So it comes here now to 9. Then 9, when I is 9 and the high value it's still 9. You see? So it becomes 9 plus 9 divided by 2, which is 9. Then the value of 9 is 44. And then you compare 44 with the target value, which is 44. Now our search is successful because that is what we have been looking for. Yeah.
Now, Linda, can you try, for example, your search value is at index 42. Maybe that 44 to be at index 42. Let's assume that our search value is at index 8.
So you want to say like
Yeah,
Like
just swap 42. Yeah,
I
that way
can't
to
swap I can't swap them because now it's binary search and they need to be sorted.
no, I used a wrong term to explain it. I wanted like you add there 44.
Yeah.
Just type 44 comma, and then on the other side you add that 42.
No, it can't work because this one, it's not assorted. It works only, binary search works only on assorted list.
Okay,
So if it's like this, it means you have to do something. You can now do the sortings because now you want to sort them to make sure that they are aligned on the same order. So it will not work because it needs to be.
We put 42 as a search value as a target instead of 44.
Pardon?
It will still work. What he's trying maybe to demonstrate, if we say we are looking for 42 instead of 44, maybe we can still demonstrate what he's saying. So instead of our target value being 44, it becomes 42.
So you want me to try it if it's 42?
Yeah, by day. Try that. Like I try to explain how you'll access that.
So let's say this one is not there.
No, it was just fine. But now you're searching instead of searching for 44.
So we are doing 42. Okay, let's go again. So we'll go 0 to 9, right? So we got the first one, we got 27. Is 27 less than 42? No. So we move ahead, we move here. We go 5 plus. Yes?
Is it, you see from where, from mid plus high?
Yes.
There is that first pass.
Yeah, this is the first pass.
Yeah, can you just select everything and delete? Yeah, so our target value is 42.
Yes.
So we are looking at the lowest value is 0, just write 0. Isn't that what we're saying?
Yes, that is what I'm saying.
Low value is 0, and then the high value is 9.
Yes.
So we are going to add like.
So you start to find the midpoint. So we look at the mid value, or somebody can say the midpoint, right?
Yep.
So we start with our first pass. Let me try writing decently so that it looks good. So our first pass will be 0 plus 9, then divide by 2. What do you get?
You get 4.5.
Yeah. So you can't pick 4.5, you pick the lowest. So it's 4. You stop at 4. You check the value that is in index 4. What is the value at index 4? 27. You compare 27 with 42. Your target value. Is it greater than or is it smaller than?
Okay, just right there, 27 is less than 40.
So 27 is less than 44.
Less than 40.
Right?
Yeah, 42. You're looking at 42.
Less than 42. So this means we move right. Like it's like you are changing your I value to the next value, like the one that follows it. So for example, when you stop at 27 here, because that was the fourth the fourth index, that now that was our I. You see, but we have realized this value is not the one that we're looking for. So we move ahead plus 1. That is mid plus 1. Now that concept of mid plus 1 comes in. So that means that if it's less than the targeted value, you move right plus 1. But if it could be greater than, you always move left, but you minus 1. Because now you're looking at a value that is less, it's greater than that. You see? So that means after looking at 27 is less than 42, this means we are going to go to our second pass. Because our first pass is wrong. You see?
So there.
Yes.
There.
Yes.
I would like you to copy value starting 31 up to 44. Just copy those values.
Okay, there's no problem.
A question before we move ahead.
Yes.
So you said if the value was on the left,
yes.
So it was a number like 19.
Yes.
That means we ignore 27. So we come index 0, 1, 2, and 3. We won't use index 4 at all.
Exactly.
Okay.
Yeah, that is what it's doing. Because now you see, you'll ignore the right side because if for us we are ignoring the left side, because what are you going to look for 10, 14, 19, 26, and we know very well 44 is greater than 44 is greater than 27. So that means definitely 44 is on the right side of 27. Yeah.
Yeah, exactly.
What I was clarifying is every time we ignore the midpoint. Once we get in, like if you are looking for 19, it's less than 27. So we ignore, we won't bother with the midpoint, like it won't be used when we
exactly, unless it will only bother if that midpoint is equal to the value that you are looking for. For example, if a coincidence happens that our target value was 27 and you happen to do it, then you get 27, then that is it. That it will stop there. But so long as it's not equals to that mid value, you have to go on searching. So you ignore that midpoint as you are saying you are very 100% correct. Then you move now the direction that you believe that mid value is. Are you okay?
Linda, I have a question. How does this work when you have a duplicate?
I don't think you can have a duplicate because does it have a, I don't think so, because we are now working with sorted values and we are doing, does it work on
okay.
I'm not sure. Maybe somebody
can respond. Can I advise?
Yes.
For us, not like to confuse ourselves, because you're all learning. I'm suggesting that we finish this one first, then you look at the duplicate. Let us understand this, then look at the duplicate. Because I've realized when you start like bringing in other what is like this, what if like this, that is when we start like sitting here for hours. So I'll advise you finish this, then you look, is there a possibility if you have a duplicate? Can it work? My suggestion though.
I agree, because we'll be all over the place. Let's finish this first.
Is everyone okay?
Yeah, and before you go on, Linda.
Yes.
For my understanding is that like for now we have now like discarded the first part. We are only watching out from index 5, which has 31 to 44. That is what we are concentrating on the second part.
Yeah.
Okay, thank you.
So I think even that person who suggested that, like, that is a good idea, because now people will see what is happening. Thank you so much to that person, because I'm not seeing the screen. I can't know your name.
Ibrahim, you're welcome.
Okay,
or Ambali, call me Ambali.
Yeah, thank you so much, Ibrahim, because now that makes it easier. So after we've discarded now from that one, the left side, now we pick now mid plus 1. So we pick from the 5th index to the 9th index. Then you come and check what is the low value. The low value is 5. What is the high value? The high value is 9. Then you divide by 2. What is 5 plus 9 divided by 2? What was it? 7. It was 7?
Yep.
Yeah. So for 7, yes, for 7 we get the value under index 7 is 35. Then you compare it. You get it's less than 42. So this means that we move right again. And we change our ith value to, like you add the ith value to the next value. You can say I plus 1 or mid, because our ith value, we know it's the mid, like we are moving from the mid. So you go ahead and you take mid plus 1 or the ith plus 1. It doesn't matter what you call it. So you go to the third pass. And you go, now we have 33, 35. Yes, you can just stop so that you don't just stop.
Linda.
Yes?
Is it 33 or 42?
See, it's not, see, we were here like at 5.
No. On the second pass,
31.
we have done, yeah.
We only have
No. You only have 42 and 44. That's what I'm. Yeah, thank you, PG. That is 42 and 41, not 33.
Where?
No. Just delete that. I think you have only remained with, because you have moved from index 7 to index 8. And at index 8, we are having 42. At index 9, we are having 44. So I think those are the only two values that you are looking at.
We only have 42 and 44.
Yeah,
Right.
exactly.
Yeah, thank you so much. So this will be, so we are at index 8, right?
Yep.
Then you are at index 9. Then you do the same, 8 plus 9 divided by 2. You are getting 8.5.
This is 17. Yeah. 8.5. Is it 8.5? Mathematics is not even in my head currently.
Kindly help those people of calculators.
It's 8.5.
8.5.
8.5.
So it definitely will be 8. So the search is successful because you can't move ahead. You already 8 is 42. Because if you check 42, it's equals to 42. So that means it's successful, unless somebody is not seeing it.
Now, based on what I've been following what you've done, so basically on this explanation on the binary search, before it does the midpoint or whatever, it begins by first checking the starting index 0, the index 0 before it does the binary. So like for example, if you have the first, you can go up to your list, original list. So so like that part where you have 10 up to 44 all the way to 44. So it means before it does the binary search, it begins by checking the first starting index if it's 0. If the element that you are searching is at that starting, search is like at the starting point, then it will return. So, but if it's not in the first starting point or at the start index or as index 0, then it's gonna do the binary search. Like it's going to divide it's going to divide in two portions. And if the value is not in the first division, then it's going to check again in the next division. So in that way and so forth. So it means that it begins searching first of all the starting index, right?
Yes.
Okay, I think that's clear then.
Yeah. So anybody who is lagging behind, so that we now implement, we are going now to implement the code. Now, and I want us, the reason why I want us to do this way is I want now for you to see what is happening in the algorithm, because now you'll understand why there is something, it's being written this way and why they are doing it this way and why something like that. Yeah. So I think if anybody has a question, you can ask before we implement.
Linda.
You can ask. Yes.
Linda, I don't know what members will advise, because there's someone, I don't know his name. He had asked, what if you have like duplicate? So I don't know whether to do it like this one for a duplicate, because I've already understood this one, or we do first of all the function, the Python function, then we come back for a duplicate. I don't know what guys are advising.
I think I can try maybe to answer that. So for example, an instance where you have duplicates, so it's going to check on the original array, and then it's going to check the first element. So let's assuming that it's a string, it is strings of values, and then I will have, for example, the like for example, let's say you have mango. So it's going to check on the original string, and then it's gonna check on the arrangement of that on that element. So the DNA is going to look on the first instance of that, on the first instance of that search value, and then it will ignore the rest. So it will only consider the first instance of that search value, and then it will ignore everything because it has found the target value.
Yeah, thank you, Nema, for that.
Yeah,
I don't know.
The moment you find the target value, that is it. And also, it will depend on how you personally, as a programmer, you'll implement your algorithm so that it understands it's going through. So it's not like it's going through the list and it wants to get the number that, because you see, like if you have 42, if you had 44, then 44, then 44, then 44, you see, like already it got the first 44. So definitely it will just give you, I think, the first one, if I'm not wrong. But I did not try to search that, and I've never tried to do that. Okay, you can talk.
I just wanted to ask whoever had asked, because me I've understood from Nehemiah's explanation.
Yes.
I just wanted to ask whoever asked that question, are you okay with that answer before we move on?
Hello. Okay, can I clarify something on the duplicates?
Yes, please.
Okay, so let's say that when the list of arrays, let's say, for example, like in a contents, like we have like, maybe in the list, we have like 1, 2, 2, 4, 6, and so forth.
Yes.
So with the duplicates, it depends with the first encounter of duplicate that you want to check in the list. For example, in order to maybe have more control, because when there are so many duplicates in the list and you don't personalize it, or maybe you don't, let's say, you don't have much control over the duplicates, it depends with the kind of the algorithm that you are going to write. For example, when there are like, let's say, 3 2s in that list, and you want to maybe only return the first duplicate value, the first value that you find among the duplicates, you can implement other techniques like using the lower bound and the upper bound. So there are various techniques that you can implement when working with the duplicates, because when there are duplicates and you don't implement those techniques, most likely the outcome may be very unpredictable in finding the occurrences of the specific value that you're looking at when there's a duplicate. So it's either you distinguish between the duplicates, or you can use lower bound and upper bound to maybe find the first duplicate or the last duplicate within the list. I don't know if it's clear.
Yeah, it is.
Yeah, that's very, very clear.
Yeah.
So by default, it's gonna check on the first occurrence, but you can now initiate, like you can implement in such a way that it can check either the upper bound or the lower bound. But by default, it will check the first instance. If you don't specify, if you don't specify the bounds, the worst case or the upper bound or the lower bound. So that's very clear. I think it will help many.
Yes, if you don't specify, the first duplicate that will be encountered with is the one that will be taken into consideration.
Oh, let me ask Ronnie. So if for example it was a sorted list and we had like maybe 2 duplicates, it will only return like the first instance of that duplicate, like in a linear search. Amando.
Okay.
Yes, if you don't specify, okay, normally, generally, I don't think, but one thing I know with that is that it can be unpredictable at some time, though it really depends with the kind of the algorithm that you've written. But normally, when it's just a normal one, it will just look into the first encounter of that specific value. It will return the index of that first encounter.
Okay, just like
but
in
in order to have more, most probably, yeah, just like in a linear search. But in order, if you want to have more control over it, you can implement those other methods, like using the upper bound and the lower bound. For example, like when you use bisect in your code, like let's say, for example, you implement the value that you're looking at, bisect to the left. When it bisects to the left, it will look at the leftmost value of the first encounter of the duplicate. Or when you want to bisect to the right, it will look on the rightmost value of the first encounter.
Thank you.
Okay, we are moving forward. Like, if you know you've not understood, you ask before we start implementing, because I want us to implement. I'm not using the explore AI, the pseudocode, but the pseudocode they explained one. But I want us like to understand, like we are doing it practically, like we are doing what we are doing. We are seeing the binary search is doing, so that even if you are in an interview or something, you can get you can be able to understand when somebody tells you, can you showcase this and this, maybe in an aptitude test. It will be easier, because I usually believe if you if you copy a code, you'll never understand how it's working. So let's start. So I want us to go just the way we've been doing, like step by step. So let's say we define, can we define our, how will we define our function? We can say def binary search. So I want us to go step by step. So from there,
The word binary is misspelled, not unless you will write it the way you have written it in subsequent.
I'm telling you, I always have a problem with the typing. Binary search.
Maybe you should try using short forms.
Yeah, so that I don't
Just write define binary by search.
like that.
Eh,
Yeah, thank you. So can somebody tell me what will be inside? Like what are we calling? What will the function define? We have our list, right? Then we have our key value, or what can we call it? Target. Let's call it the key value that we're looking for. So there we are okay. Then after there, what did we do? After we had our list, what did we do? What was the first step we did?
look for the midpoint.
No.
No.
We said we took our low and high value.
The lowest and highest.
Yes. So our low value was 0. Then our high value will be, what will be our high value?
Was 9.
So it will be length of
Length of the list
then minus
minus 1.
Anyone who is not understanding why it's minus 1? It's because our entire list, like here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we have to subtract 1 because we are not counting from 1, we are counting from 0. Right? Okay, so we now go ahead.
Change the list. It's supposed to be my list.
Yeah, thank you. Okay. I want to use the while loop. Will it start from here? Because I know the indentations will do wonders. Okay, let's do it. So we start. So we can check, maybe we were looking at if the low value is less or equals to high. If low then we went ahead and
you forgot the colon.
oh, thank you. Yes, please, if you see, thank you so much, because I'm just typing, so plus high. So we did say that if mid is equals to low plus high, if you divide by 2, then you find out that, make sure you help me for the indentations if I'm doing it wrong. Then after we've calculated mid, we came and said, if we get the mid of this list, here will be my list, sorry. My list. So this means that if the mid of the list, we get it equals to the key value that we're looking for, what do? We return the, if it's equals to, we return the mid, because that is the, like,
Sorry.
You have gotten it.
Didn't realize that.
Sorry. So that means that we calculate the mid and then we divide by 2. Then if we get that the mid is equals to the key value, we'll return the mid value. So that means if you return the mid value, then that means your function will have worked, will have gotten it, because that value that you're looking for, the mid, it's equals to the key, then you don't go on and search. But what if it's not? What if it's not? What did we say if it's not? Make sure you help me so that my indentations are right. I'm not sure if these indentations should be from here from well, but we'll check after running, we'll understand. So else, who knows after here, if you realize that your mid is not equal or equals to key, what do you do?
Mid plus 1.
You so it will depend. So it will be if the key, so else
You have to check whether the mid is greater or less than the key.
Yes. So if you get the key is less than, it's my list. So what happens when you get if you get that the key value is less or equals to the mid? Or if you get one, do you add or you subtract? Open your eyes because you did it.
I think you add.
You add one.
So you add one to the side of the low or to the side of the high value.
You add one
to the low value.
To the low.
Yes. So low is equals to mid plus 1. Right? Else high is equals to mid minus 1. Then if it's not, I don't know if the return now will be here, the other while.
Return false.
Exactly. Or return minus 1, whichever. Let's see if it will run, but that is it. That is out there. Like we've written from our own understanding. So let's see if our one is okay. We have a syntax, so
the while loop, while if.
So it's while. It's not while if. It's always just while. We have another syntax error where
return equals to mid. Is that supposed to be return equals to mid?
It should just be return mid, right? Yeah. Another one, we have another syntax error. Where is it? Is it on this one or this one? Or it should be like this?
I think that one should be in what do you call it? An algorithm. Indentation. Yeah,
ident.
And then
we have another one. We have another one. So this one is
your code again is not correct unless if you are to use the elif. You can't have two else. Either you use the elif or a nested.
I can remove this one actually.
Why can't you use if na elif then else?
Yeah, I think that's easier.
Where
you do if then follow
the second iteration is
elif then else. I am just trying.
So where the second if is right elif, not if it becomes elif.
Elif,
Here? Yeah, I think I'm writing. Okay, we are writing like we've written this. Actually, we've written this code from scratch. Let me just tell you because I even didn't write something like that. I'm even shocked. So I've just written it like we've implemented it exactly from what we had done earlier. You see? So can somebody say if they have difficulties or they are not seeing what is happening? You can talk so that we can move forward. Before we try it on, we can try it on a list.
Let me ask.
Again. Okay.
Yes?
Nema continue and then I'll ask.
Yes, Nema.
Again, Linda, our code is not like logical. Now, whenever you have that return else, return, for example, or in the same block of code or the same indentation with your while loop, so it's gonna ignore everything that is you It's correct. It's correct. I see where it's.
And even here, so you can just say if here. It's still the same thing. If
No,
my
you
list,
can't use that.
if my list,
You can either
it can't.
you can only use elif.
Okay.
See, it is if, then elif, then else.
Okay.
Now,
Question.
Can you call it so that we see the output?
Make sure. Okay. Make sure you help me because I've written it. We've written it together with you people. So just make sure that you have done the right thing.
I'm wondering, under that elif part, we are saying if the key is less than the mid, would that need to be high is equals to?
No, it's low. Okay,
the key is less.
Interchange it. Can you interchange it? And then you reason. If you find that
okay.
It's you see, if you interchange it, you can understand now. If you say my mid is greater than the key.
Ebu run it. We see.
You can't run it first of all. You need to have
We try it on a
list.
Yeah, let's try.
Just try it on a list to see if it will make sense.
Yeah, let's try to print. Then let's say we call, how will I by search.
And even before we print, I think we should have defined our list. For example, the list of our arrays, or maybe you are going to do it later. And then now you define also the target.
I wanted to combine it, but it's
yes.
Sometimes just let us make errors first. What are to make errors? After making the errors, you will understand. Because me, I'm just watching. You have to make the error and then you rectify that error. Then people will understand better.
Sure.
Just let those errors flow.
You want first of all someone to fall in the pit, and then
yeah, let us fall when we get out.
Okay.
Let us fail first.
Yes, that way we understand our mistakes better, like we understand why we didn't need to do that.
Okay, is that okay? Is that correct?
Yeah. So that's wonderful.
Oh, this is good.
The print is not defined.
Yeah.
I remember whenever you've
What are we looking for? Which number is that?
Yeah, we don't have the arguments. Thank you.
So you say by search my list. Okay.
So the key value was 42. No, ours is 20. Let's place like 20. So from there,
run with it.
No, you can. No, if you run it won't work because let me see.
Again, you because you've used the return statement, there's no need for the print because it will. But just do it your way.
It's still not working.
By such missing one required position argument key.
It wants you to put my list, comma, key inside there. You see that final print? Print by such both arguments.
Now it became worse.
It's getting worse.
Yeah, something is that we need to know how to print, to call a function to do this. So that means.
Linda.
Yes.
I have a suggestion. Before we go, can we just go up there so that we see the whole function? There. Is there anybody here, Nehemiah, Nemo, PG, or anybody who can explain this function from the word def or define to the last word false, so that people can understand? I believe that way, after people have understood, we'll be able to pinpoint where we're going wrong. Can someone just explain without adding anything else? Because when you add anything else, we are out. Just the way, what is this function doing? Only that. From there to the last. If there is anybody who is able to.
Any other person who wants to
You
try?
have so much faith in me.
Yes, we want a different person.
Let me try.
Thank you.
But explaining is where do you want me to start explaining?
Like
Sorry, let me interrupt before Nemo explains. We have the two ifs we have. There is one we say my list, parenthesis, mid, and the second one we have my list, and then it's like an index or a list mid. Don't you think that's where the problem we have? That's why we are being told we cannot call, it's not callable.
I think, Linda, it's the other way
One of them
around.
has parentheses, the other one has square brackets.
I don't think that's the problem. It's supposed to be like that.
Why is it like that? Because
it's easy to explain it in ngumu.
Just explain, because I'm wondering, one of them has my list, then the mid is
Oh,
equals to
yeah, I understand. When
then
you
the
say
other one,
my list mid.
Yes, so one of them has parentheses, the second one has
square brackets. Maybe, Linda, you try to change that, we see if it will work. Hello? The presenter has gone.
I think it could be network issues. Sometimes. But I would really love if somebody can at least explain, because if somebody explains and then people understand, them themselves will be able to pinpoint those errors. Because like currently it's only a few people that are seeing the errors, but maybe the majority are not even seeing that error.
I think Nemo will be able to explain. We just wanted maybe to point that out so that we see whether we have an issue there. That's why it keeps telling us that it's not callable. Because we are trying to call something in square bracket or something like that. That's like an indices.
But you
Before she comes back, I heard that we're doing this so that you can do it the practical way, because someone can be asked in an interview.
Actually, you have to understand.
I can be asked this in an interview.
Yes. It is a basic this is a basic algorithm.
Oh boy.
You have to understand it.
Gosh.
But Ibrahim, have you understood why we do how a binary search works? Ibra?
Nemo.
Yeah.
Yes.
I've not understood everything, but the basic thing that I've understood is that the values in a list are supposed to be like either in ascending order or descending order. They need to be sorted out. That's the first thing.
Yes, that's the first thing.
And then from the earlier explanation that Linda did, is that we add the lowest index value and the highest index value, and then divide. And then when you get that, you have a mid value, and then that mid value will either now, that mid value, we compare that mid value with the corresponding value in the list. So we try and check the value that we're looking for. Is it along that mid value, or it's on the right side or on the left side? And then we make a decision. So when you now make a decision, whether if it is on the right side, then you go to the next value. The mid value could be 2.5, so we go to 3. Then from 3 onwards, we pick that like a subset, then redo again what we did on the first step. That is my understanding. Yeah.
I think you've explained it very well.
Yeah, but you see now, this person also need to understand what is while doing, what is else is doing, what is returning. I think if you understand that way and other people understand that way, we can be able if something goes wrong, okay, maybe this is the best. Yeah.
Like you see, like where she was using while you want to compare if the low is it the index? Yeah, the low. If you want to compare, like low should be less or equals to high. Yani it should be less than high. You understand?
Yeah.
So that you calculate the midpoint. You understood there? You calculate the midpoint where you'll add the low and the high index, then divide by 2. Okay? You've already done that. Then you've gotten an answer. You come to the if loop. So this is a conditional. If the midpoint is equal to the key, you will return the midpoint.
Yeah. And that midpoint will correspond to that value.
To the key is what you are going to see.
Exactly, yeah.
Like if you said, maybe if you go and you divide, you get the midpoint is 20 and the key is 20, we will return the midpoint.
Yeah.
You understood?
Yeah.
Else, if it is not true, we go to another conditional, which is an elif. Sasa, where you say, if the key is less than the midpoint, okay?
Yep.
You take the low, which is 0, the index of 0, then you add 1.
Okay.
The midpoint plus 1, so that it can move. Like you're moving to the left. I think to the left.
No. I think to the right.
To the right.
Yeah.
Please join it. I don't know left and right. I just know you need to add 1 to the low.
Yeah.
Okay?
Yep.
And then, if that is still not true, we say else, it should do something else. Okay? You can and say, to the high, you take the midpoint, you minus 1.
Okay. From understanding that on that else if is that if the key now, if the key now is greater than my least midpoint, that is why we will now like what
greater than
minus what? Understanding.
Goja, if the key to say, let us use numbers. You've calculated your midpoint as 20, sindio?
Yeah, exactly.
And then your key is to say your key is 18.
Yeah.
So it is going to take the low point, you take the midpoint, you add 1. Okay? As in a list, like in this list, 1, 5, 9, 15, 20, 23. Like that. If it is here, let us say we were looking for 20. We are at 20. That is 20. Our midpoint, let's assume it's 15. Our key is 20. Our midpoint is 15. So at this index, we will add 1 so that it can come and check 20. You have understood?
Yeah.
If, for example, the high point is 23, we were looking for 20, we will minus 1 so that it come and checks 20. That is the best I can explain.
Yeah, and that is why you're having else. High equals to minus 1.
Okay. Because we have started like, if the midpoint is the same as the key, you return the midpoint. If it is lower than the midpoint, you add. If it is lower than the midpoint, you add 1. If it is higher than the midpoint, you minus 1. Okay? From the high. That is, I think that is, I have understood up to there what we are supposed to do. Why we are getting errors, I think the logic is good. Why we are getting errors, I have no idea. Linda, I wanted you to do this. Can you, if you were to interchange low and high,
yes,
you put the high, in the elif you put the high, like you copy high is equals to mid minus 1, and then on the else you put low is equals to mid plus 1. We see if it will work.
So if you do that, it means this will be greater than, it will interchange.
Because what okay,
you've seen it will interchange.
High, just put high, mid minus 1, then low. I'm just, because...
Okay, okay, so they actually... Yes?
When we say my list parentheses, square brackets, mid,
Yes.
isn't that checking the index
Exactly.
at the mid level,
Yes.
which we are trying to compare to the key? Shouldn't it be my list, then round brackets, mid?
No.
To actually point out the number at the mid. If the key is less than that number.
No, it will be square
Because
bracket.
you know why because when you are calculating the mid, you are not using the I value. We were using the indexes. And that indexes is when you are getting the index, and then you compare it now to the element of the value in that list. So you can't use your
Actually, Linda, the first mid should be also in square brackets.
Which one?
The one first, the one you got
That one.
Yes.
I was
One of them had to be that because I was trying to understand what we return the index and what we return the key.
Okay. So yeah, the person was saying we change this one to high, then this sign will interchange, will be greater than. So you want me to do that?
No, I was just trying. Just revert it. Me, I like trying, then I get errors, I go correcting until I understand what I've done wrong. Just if the logic doesn't make sense, it's okay.
So
Maybe you return it the way it was and then you correct it, we see if it will accept. Sindio?
Yeah.
Mid plus one, we see if it will work.
So is it okay?
Yeah, it's okay.
Actually, what happened,
Exactly. It's saying false.
Yeah.
Why is it saying false?
I think the problem is just, we've written from scratch, so I think it's just here on the, how is it called?
Can I maybe?
Yes.
Can I just try to explain this thing? Like I will just use a new cell. I want the beginners to understand these things in details.
Yes.
Other than guessing things, we can do it like from me. So let's do this. Let's give our binary search. Let's define our function. Let's just do a div. So just call it the binary search. Then our arguments there can be, for example, what can you call it? Just use an array or anything, and then call it target. Let's make it symbol. And then I think before we do the coding, anything, let's define there at the bottom the target and the list, the array list. So I think without the indentation, we shall come to the coding later. So at the bottom, let's define our, let's define what our, the list. Or you can call it maybe something like a sorted list. No, that part is fine because that's what we shall call it in the function.
Okay.
Yes. Just let it be array, and then for example, let's be descriptive. Then I call it something like a sorted list. Then you can add there any sorted elements. And then so target, you can give it whichever number. So I want us now to return back and begin now to code. So let's define. We are using now the local scope variable. Remember that any variable defined within the function are called the local scope variable. But any function that is defined, any variable that is defined outside the function definition, they are called the global variable. This is just something that you can just know. And then so let's define our variables. You can say, for example, let's call our load to be 0. Remember, it can be anything. For example, you want to begin your search from maybe at index whatever, you can define whichever you want it to be. And then to make our work neat, you can do we can do it. We can do the. Oh, it's fine. If you want to do it that way, then I'll do it. Yes. Yes.
Sorry to disturb.
Let me just return the code that was here. I deleted it.
Sorry. Okay. Yes. Yes, Ian.
Ambale. So, there's something that was mentioned very, very crucial, which I think I was also not understanding. You have just said that law, just turn to that. No, to the code that Nama was telling you. Yeah, you see, you said that law equals to 0. Then if you look at our list, at the started list, you are starting at 1. So that law equals to 0. It means that is where we are starting to search. That is what it is.
Yes, exactly.
That is something that I was not understanding. Thank you so much. God bless you. Bye.
Yeah. So I wanted to do it the way you had.
Like this.
The way you wanted to do it the first time. So in that case, if you are to do it that way, you could have said first of all, do this, say low, a comma, and then a high, and then you'll assign here there to 0. If you wanted to use like a single line what? Variables that you remember that you can define multiple variables in a single line and then assign the values and the same. So if you are to do that, then I think that could be the efficient way. However, you can do it either ways, like doing in each separate lines. But yeah, so let's just do it our normal way. And then a good practice, if you could have, if maybe you have written the entire content on the Athena, you could realize that they said that whenever you are defining a variable, you could have added one space. For example, you are defining your variable, you say law space, then you are before then the law also, to make our work to the best practices. That part where you have the law. This is just it's not serious, but are the best practices. So you've defined now the first one. You've defined the starting, like your low, the lowest, or at the starting point, the lowest, the where you want to begin the searching. And then now the second one, you are defining the length, the highest point. I think that should be the good thing to do. And then so the next section, you can add in once you understand maybe that PEP8 is called what? Python exceptional, proposal. They say that after you've defined the variables, you can add in one line, a space there at the bottom. Then you can add in the condition, like to make the work neat. Then you can say, for example, while, and then while low is less than, you can add in the space first of all. Sorry for disturbing you, but I want other people to. And then a high, then a colon. Yeah, colon. So we need to define our we need to define the mid. Sorry. Yes, in that minute's time niko kwa meeting nikupigie baadaye please. Okay, yeah. So basically, that we need also to understand what that operation is. You can scroll down. You see, in fact,
I have a question, Nema, before you continue.
Yes.
On the while, the while low is less than or equal to high. So in this line, in all the instances, it will always be constant. It will always be like this. In all scenarios.
Can you rephrase the question, perhaps?
This while low is less than or equal to high, is this always going to be constant in all the scenarios?
I think someone who has understood can try maybe to answer.
I've understood the question, but I don't know the answer. Maybe if I explain
it. Maybe in other scenarios it will be different, or always will be starting with that while low is less than or equal to high. That's a standard thing in binary.
It is.
Okay.
Okay. I think it will always be constant because you find that when you look at normally the value that we have assigned low is 0. So the target can never be less than 0. So that's why we find that while low is less or equals to high, is less or equals to high. For example, high cannot be less than low. It can be equal to maybe, well, let's say when there is only one value in a list, of which when we're searching among the values in the list, there will be more than one value. So it will always remain constant.
Okay, thank you.
Okay, thank you so much for that. And I saw, Linda, you had already written that part where we have low plus high plus, then a 2 on the first slash, then a 2. Because you are the one who wrote, you can explain perhaps before we proceed.
So there you see that came here when you were doing it, like after you've seen the low, then you've seen the high. Now the next thing is that, since the way you said that the first condition is you look at index 0 and you look at the value. If the value is not equals to the target value that you want, now we go ahead and we start now doing the midpoint. Now we start looking at the mid value so that we can is it divide and conquer, so that you can divide and get the midpoint and understand where our value lies. And that's why now we come in and bring in this condition of.
So my concern, maybe people will want to understand why 2 first slashes.
Because I read some. I had.
Okay, maybe to simply put, here
I
we are checking.
know.
Great.
Okay, the 2 slashes, if you put 1 slash, you see, like when you are dividing, then you are getting 4.5, you see? So the second slash helps us so that this algorithm, when Python runs it, when you get 4.5, it picks the lowest, it picks now 4. It doesn't pick 4.5, it picks 4. So when you get 8.5, it will pick 8. If you get 9.5, it will pick 9. That's why we have the 2 slashes, if I'm not wrong. Yeah.
Okay, can I clarify further on that?
Yes.
Okay, so you find that in division, for example, the reason why we're using 2 slashes is because we're using an integer division. For example, in our list, a list should not, in the list of, when searching a list, the list should most probably, the list is normally contain all numbers.
Yes.
That most likely are integers.
Yes.
So the double slash is an integer division. It's not the same as the single slash that can give you. For example, when you find that when the total sum of the low and the high is an odd number, when you divide using the normal division, it will give you a float.
Yeah.
Whereas in the list, it should only contain all numbers, that is integers. So when we use integer division, it only returns the integer part, omitting the float part that is after the decimal point. So that's why we're using an integer division.
Yes. And just to make it short, the way I've said it, this means that anytime you get if this is calculated in Python, if it ends up getting 4.5, it will not give the float, because if you had just done this, then it will pick it as 4.5. But if you do this, it goes ahead and picks only 4. Now the output value will be 4. And that's why, as you were demonstrating, I told you when you get like 8.5, you realized I told you just it picks the minimum, like it doesn't pick the float value, it picks the 8 and not 8.5. So I think your explanation is very much okay, and it's the perfect explanation for this. Thank you so much.
Yeah, that's wonderful. For me, I always like to be like thorough so that people understand literally everything we are writing there, so that so that no one can don't understand anything. So basically, that's just whenever you use the 2 forward slash to make it simpler, it's like a float division operator. Remember we talked about the operator. I think Kelvin was present. He taught us about these operators, and I think he touched on the flow division and such stuff. So basically, this one will and just as the way you've explained. In fact, I don't want to add anything. So just know that does the flow division. Now the next thing, let's try to define now the mid element. And the next line. So you can use because they are variable related elements, you can put them. Don't use a space. Don't like create an extra line. Yeah, that way. And then let's just use something. Let's just call it mid element. Let's just define our mid element so that it can be easier there at the bottom. Mid underscore element. So who can tell us the mid element will be what? You can create a space, then equal. And I remember, guys, while we were introducing variables, we said that whenever you use the equal or a single equal operator, you're not equating, you are assigning the values to that variable. So in this case, for example, you want to assign the mid elements to, because we are going to do some calculation, perhaps you can delete the second equal. So basically, if you want to like find the mid element, basically what you'll do, you'll use what? You'll use the array. You'll first of all define that array. So space array. So remember the array returns what? The elements. You know, the sorted elements in your list, right? But now, because you are targeting the midpoint, and at the midpoint we've already defined there with the mid, so you can use the square, and then there you just pass the mid, because in that array we are only targeting what? We are only targeting the midpoint, right? I think up to that point people have understood. Before we go now to the conditions, the real implementation. Yeah, so you can add a line break, yeah, like that. Then we can say, for example, if mid underscore element, that variable. If you're not good with the spellings like me, there's no harm when you do copy paste. So when mid element, for example, then space equals so you'll use yeah. So if it's target, then a colon, you'll do what? You'll return the mid. Yeah, you return what? The mid. Because we are saying this, like for example, you are searching for a certain element, and then it's not in the between. It's not like it is just direct. When you are doing the mid, it's just at the midpoint. So when you get that element at the midpoint, just at that position, when you've done the mid and you find the element, so it will return the element because you found what? The element. But if it's not the case, you can do the elif, or you can use the if you are to continue with the if, you could have used the inner if, but let's do the elif, is much easier. So elif, if that element is less than the midpoint value. So so no, use mid. If mid underscore element, if the mid underscore element a space. Sorry, I'm disturbing you a lot.
No.
So if that element is not the exact value at the midpoint, which means that it is less than, what can you do? And then you are going to do what? You are going to like do another operation there. You are going to again, you are going to, let's now say low. Let's append let's do low. It's just fine. Let's just fine. So low. Then you can assign the mid. You know, the mid plus 1. The mid plus 1. Remember, I want to explain. Someone talking.
Fayemi, kindly mute.
Yeah, so the reason we are not, you can create a space. Sorry, I'm disturbing you a lot. But that part where you have the mid and a plus, try like to make your work be neat. Yeah, space plus and then a plus 1. So essentially, because we are saying that, for example, if you are to check on a list, and then the element that you are checking is just at the first position. So in that case, I said that you don't have to do the mid calculations. So assuming that the element is not at that midpoint, once you've done the calculation and you see that it's not the midpoint, so you'll check the starting point. The starting point is the value that you're going to access without doing the mid operation. That's why we are adding the next value. So the next value is going to be the starting point of the other mid operation that you are going to check. So essentially, it's going to check the mid value, and then it's going to check the starting value of the next. So if it's not true, if it's not that value, then again you can now, for example, add in the else. Yeah, the else. Yeah. So I like the way you write it now. So then you can assign a high. High, you'll give it mid. It will be mid. Should be mid.
Yeah.
Mid plus -1 now. So essentially, you've checked that the midpoint is not that value, and then I've checked the starting value of the next value is not that value. So what you'll do, you are going now to do what you're going now to check now the values that are less than. So that's why you are going to begin from the mid backwards. That's the operation that is going to be done, that way. So now, if all this condition is not met, if all this condition is not met, you can add in now the return statement there. It should be in line with that, a while there. While. So if that value is not available in that thing, then it's gonna do you can return something, yeah, like that. So and then now we can do what we can do it. So perhaps let's do this. In fact, once again, I'll have to disturb you all the time until you create the spaces, because that's the best, no, that way is what was fine, but after the operators, those things, I have to disturb you. Yeah. So now, because I don't want to pass everything in the whenever you are calling, let's create another value. After that 10, you can do a line, and then let's instead of calling it direct, because I saw earlier you are trying to use the print function, so let's try to create a variable for our call function. So you can call it, for example, something like a result. A result. Then you are going to assign to the function. Now you are calling the function. Binary search, and then you are going to pass in the argument. Sorted list. And then no, it should be now the target element.
The target?
It should be target element. Remember, let me just try to explain this to you. So like whenever I say that whenever you are defining a function, there are things we call the arguments, the parameters. We call it parameters. So anything that is the values that are there after the function definition are called the parameters, and then the values that you add in, the real values now, are what we call the arguments. So the values there at the top, these are just like variables. So you don't have to use the same name like you don't have to use the exact variable name there. So here you're going to use what? Yeah, that's fine. Yeah, so the argument there is going to be target underscore. Yeah, that's fine. So, and then now we can try to do like our operation. Let's try to be, before you run, remember it won't execute anything because we haven't implemented anything there. We haven't yes. So what you do in the next line, after that function, we call it, let's try to or can we do it? Can we like check?
Nehemiah, before you continue.
Yes.
Okay, target element. Where has it come from? Because I thought we are introducing another variable or something. Very confused now.
Okay,
Hata mi naona even if you just write target is equals to 10
Because
and then
you
there
see,
you call binary search list, comma 10,
you see, when you
italeta
come and say
value.
target element, now I'm wondering, target element, where has it come from? This is the same way list. I was just confused. You're just
let me
something
try
is
to
introduced, then you're left wondering why it was introduced. Why can't we use whatever we already have?
let me try
Or it won't work.
No, it can work, but let me try to explain it this way.
Okay.
You know how the variables work. You can create a new cell. We try to explain that way. Create a new cell, Linda, and then let's create a variable called target. Call it target. Call it target. So essentially, the value shouldn't be the same as target. You know, it can be anything. So the value can be, for example, if it's a list. So for example, the value can be, let's use a string for instance. For instance, just define a string, sorry. Just define a string and then call it target.
A string will be?
Just define a string, then call it target. So just give it target, the same value, the same name. Just use a string target.
Double quotes.
Yeah, double quote. Double
quotes alafu target inside. Double quotes. Umeweka parenthesis.
Double quotes.
Zile quotes,
Yeah, just use exactly.
Hizo.
These
just
are.
use
Hizo double quotes. What are their names?
The speech
Opening and
bubble.
closing speech marks.
Yeah. So use
But they are double because you have single. As long as you understand it.
Yeah. So instead here use a single T. It should be the same. So that I try to explain what Nemo is trying to like. So basically, so you see the variables can be this way, but now the values, it doesn't have to be target itself. It doesn't have to be the element, though it will return, but it doesn't mean that in all occasion the value should be the same as the variable. So the same principle applies here. When you are defining the arguments, you can scroll up a bit until we see the definition of the function. So you see we pass there the target, of which now is like our variable. So we don't have to like assign the value of the target to be the same as target. That's why we gave it another variable there, target underscore element, and then I will give it the value of 10. So essentially, it's not like a must to use it can be anything. So it is
But
assigning.
you guys, Mema, in Python, you are teaching us to return what we've defined.
Yeah, see, basically we are returning. You can scroll down. You can see.
So
I think at the best
just
way.
write target.
Even if you write target,
The target is
it will
10,
do the same
bro.
thing. But now for the Nehemiah's part now, it brings
Okay. I think what you
this
do.
is, how do I say?
You see, in my thoughts, I'm thinking, even if you write result is equal to binary search sorted list, comma 10, still it will bring
Yeah, it will
the
print.
answer.
So basically, I think for not to complicate things, just remove the result things, and then just send it there. No, you are deleting everything. Just remove that variable of the result. Yeah, remember, initially, like if you have that binary search and then inside the parentheses, we are initially calling it. But now when you introduce a variable, you don't want to like call it direct. For example, you want to execute inside a print function. That's when you can create your own variable. And then, for example, you want to add in some description, some strings there, describe about your your output. Then you can create a variable. Then instead of calling it direct, you can use the variable itself inside the print function. But let's call it that way. The way it is like that is just fine. There's no harm. Yeah. So I don't want to complicate things.
So can we remove the target element becomes target?
You can do that. You can as well do that. There is no problem. problem.
Okay.
Just remove target underscore element. Yeah, up to that point, and then call it.
And then the sorted list to array.
Yes.
No, so then in that case you have to change the variables for the sorted list. You'll have again to change the.
You'll have to call this array too. This one.
Yeah. Call it array. Though guys, I
You
would advise
modify
you.
it up. Yeah.
We want to understand the basic, very basic.
Correct.
I tried running it. Yeah.
We ran it. If it reduces, we
even
know.
this one I tried running it again and it worked actually.
So in other words, you can, if it's not a must you rename.
Yeah.
It is,
sure.
which is what you feel like. If you feel like you want to rename, yes. If you feel like you want to use the same thing, you just use the same thing over and over again.
Yeah, but I'd advise you the best approach is not to repeat the same things. Like the variable names, you don't use it. Yeah, so I think that should be the best practice.
Okay. But can you say like, can you come and declare and say array is equals to sorted list and then you put the numbers there? Just asking.
Repeat the question, please.
Can I say array, like here, where she's written array, then you say equals to, it is the same as this, as sorted list, and then you come and say sorted list is equals to 1 for blah, 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 like that. I'm just asking.
So you need again to have another variable that contains the list, because when you say the sorted list and that you don't have the list, it won't.
No, I'm saying
she's saying
like you say array is equals to sorted list. And then you come now you declare the sorted list as this one for like that. Is it doable? Does it make sense or it's wrong?
Okay, let's try. Yeah, it's the same. Actually, it's like you're repeating yourself, so it's okay because the array is equals to sorted list, and the sorted list is equals to the array, so it's okay. So even if you say binary search, then you write here sorted list, you still get it.
Okay.
Yeah.
So I believe people have now understood the logic.
Yes.
So essentially, the reason that perhaps you could have decided to use either the linear search or the binary search. So assuming that, for example, you have 1,000 elements in your list. So when you do the linear search, it's going to iterate each element until it finds the last element. But now when you are doing the binary search, it's going to check the midpoint. If it's not the targeted value, and it's not within that range of between the midpoint and below, it's not going to iterate. It's going to assume that, so it's going to save that time of iteration. Then it's going to check the next element until it finds. So it's not going to iterate things until it finds. So the binary search, it can be the best option. It can be the best option. So in case you are asking in an interview, for example, you have many elements between binary search and the linear search, which one can be the best? You could say the binary search, because it's not going to iterate everything. It's going to check only the midpoint, and then if the value is below the midpoint, it will iterate. But if it's not in the midpoint, then it won't iterate. So it will save that time of iteration, and then it will go to the next half. And then it will again check if it's in that range. If it's not there, it won't do it. It won't iterate. So it saves that time of iteration, and then it goes to the next half. So this one it will save time. So I think people it is clear now.
Yes.
Linda.
Yes.
See, I thought the list should be in ascending order.
Yeah. Yeah, true. Yeah. So this is it's the binary search using iteration. Then you can also choose to do it recursively. Now recursively is what we were doing yesterday. So do you want we do it recursively?
I think we need to understand the difference.
Both of them. Yeah. Okay. So for recursive, that means for recursively, it means that a function calls itself. And anytime you bring in recursive in an algorithm, just make sure that you have two conditions. You have the base case and you have the recursive case. So the recursive case means that the function is calling itself recursively, like it calls itself recursively until it gets to the number you want. And the base case simply means that you, like, if it reaches there, like if it satisfies that condition of the base case, then definitely it terminates, or the, how can I say, or it ends the recursion, like it stops there. So it stops the recursion. So that means anytime you are working with recursive, you will need to have a base case and then you need to have a recursion case. So if the base case is true, then there is no need for you to continue. So the recursion stops. But if it does not, now you need to call the function recursively on and on until now you get to the point where you get that value in the list of the array. Or if there is any other person who can explain it better. Yeah. If not,
Before we move on, so what we were doing, what was that?
we were doing together
Sorry?
binary search.
Iterative binary search.
Iteration.
Iterative.
Okay, there's somebody who's talking.
I'm asking,
Yes.
the first bit of binary search, what, it was just binary search? Or what was it? Because I understand
This one.
Yeah, what were we
That
doing?
one was iteratively. Now she's explaining recursively.
Okay, that's what I
So this is like it's iterating because you see this while brings it's a loop.
Okay.
There is a person who can even write this code using the for loop and it still does the same work. Okay. Any other person? I wanted somebody who maybe can explain more about what recursion does, but simply recursion means a function calling itself. But for a recursion, like for an algorithm, you're writing a recursion algorithm, just make sure that you have a base case. A base case will help you to terminate, like it terminates just in case the function does not call itself. But or else you go recursive, which means the function is calling itself. Yeah.
So basically, Linda,
Yes.
from when we started about the linear search,
Yes.
the binary search, and now the recursive case,
Yes.
all these, what you're doing is like, these are different methods of searching for an element maybe in somewhere in a list or in some data.
Yes.
At the basic, that's exactly what you're doing, but using now different methods.
Exactly.
Yes.
Thank you.
Yeah, and the reason why binary comes in is because, as Nehemiah said, the linear search, you'll stay like looking for 100 elements, and they've told you look for the 100th element. Just imagine you're iterating from 1, 2, 3 until you reach 100. So you see, like the goal is to try to minimize the time complexity, like those big annotations, the way we are talking, it checks at the complexity and the performance. So you're trying to reduce it. So binary search, it makes it easier for you because you see, you when you divide or after you realize that this element is in the midsection on the right, you see, you just ignore on the left, then you go and search on the right, and then it becomes easier. It makes the time it minimizes your time complexity. Yeah.
And then, Linda, again, what we are saying under binary, we have two options. Either we do it iteratively or we do it recursively, right?
Exactly, yes.
Okay.
Any other person?
Type the code for recursively, we see how it applies also maybe.
Yes, that's what we want to do now. So we'll go step by step. Let me try write how Nehemiah wants me to write. So let's say we are binary search. then recursive. Let me just say recurse.
Now, can we try to do it like
Yes.
like a real life
Yes.
situation? Let's assume that we are implementing an AI model. For
Yes.
example, in your prompt, you have something that is not, it's abusive or maybe you're using sensitive language. So you want it such a way that if when you are searching on that prompt, then you find
Yes.
a particular word, you can say, for example, I cannot, for example, return the prompt, or I cannot
Yes.
as an AI Nini, you can say it's not like it's not ethical thing, but if it doesn't contain, you return something else. Can we implement something that in real life instead of doing or let's do it the basic way, and then I shall try it that way, so that I think people can also know how these things can be applied in the real life scenarios.
Yeah.
However, let's just do it the basic way, the way you had planned. Then I shall try it that way.
You wanted me to say, we are looking for the sentiments that people like. You are looking at the sentiments. Maybe if somebody says something bad, maybe on Twitter, you mark it as offensive, and if they say something, you mark it as not offensive, and maybe.
Yeah, similar things, such a thing. Yeah. I don't know if it's my network. I can't hear people. Hello.
Yes, can you hear me?
Yes, I can hear you.
Can everyone hear Nehemiah?
Yes, me, I can hear you.
I think maybe it was on my end. So I think we need to define the base, because that is the first step. So let's say the way Nehemiah is saying. So Nehemiah is saying if the sentiments, maybe you've taken them, maybe it's good, bad, maybe average, poor. So let's say maybe you've labeled them, like you've labeled them using integers, maybe if it's good, but that is what you mean.
Yeah, but I think also I have just realized that let's just do the example of integers.
Okay.
It can be better for people to understand. I've just realized that it's
So let me
going to be
just work with
complicated.
my list.
Yeah, sure. Just work it your way.
Okay. Okay, so I want us all to reason together. So what can be the base value? Like, for example, you have 1, 4, 10, 12, 19, 23. What base value can we equate to a list? And if that works, the recursion stops, then we can check. No, the recursion, because it's the base value will stop the recursion. So for example, if we initialize, maybe we say if the length of my list, maybe we say is equals to 0, we can say it returns false, which means that the list we are looking at, if we get it to equals to 0, it means the length of the list is empty, hence the function can return false, and we stop the recursion. Then after that, now we can go ahead and we calculate the mid. So anytime our length of the list is equated to 0, that means the recursion stops, like you don't have to go ahead. But if not, it goes ahead and calculates the mid, then we repeat the same thing. But after repeating the same thing, we need now to call the function itself, like we call it recursively. So I don't know if you've understood.
Is this where you're going to say, you say the mid, you use the mid, you say the length of the items, you divide by 2,
yes,
and then you say if the length is less or equal to 1, in that if the length is empty, that is 0 or 1, so you can't call it recursively, it terminates. That's what
yeah, so that is the best case. So we can initialize it at the start. Yeah. So let's say maybe if we're looking at the length of my list,
Divide by 2.
no. This is just now the initialization. Like you are not now doing anything.
Okay. Is less or equal to 1.
Yes, you can check anything. We can check less or equal to 1. You can, yes. Your best case is what you're instructing your computer to do. Exactly the way we were discussing the Fibonacci sequence. The best case, we took the best case to be less or equals to 1. Somebody can say if it's equals to 1, or even you can say if it's equals to 0 and if it's equals to 1, something like that. So long as you know, that will help you to, when you are calling it recursively, it will understand that anytime it comes to a position whereby our length of our list is equals to 0 or is less than 1, then it stops. If not, it goes ahead and continues with calculating the mid, then it calls the function recursively. So I think that is how I have understood. Right? Quietness means people are not understanding. Talk.
Let me ask, when we do this is where we'll say terminate, we'll say like return like 0.
Exactly, yes. You remember when we were doing Fibonacci, we were doing some base case, then we say return 1. Then people were like, why are we not returning n? Why not 1? Why not 2? So you remember? Because that was the base case. Then after that, we went and say else. Then we brought in now the recursiveness where the Fibonacci was calling itself, then it's subtract by 2, then plus is subtract by 1. So that is the same thing as here. So we are looking at, you can check any base case here. Like for me, I'm equating it to, you can equate it to 0, 0. Somebody can decide even to say less or equals to 0, not 0, less or equals to 1. Or somebody can say, you can use anything. Even you can also use, or we can do this. Let me do this. You can even decide to say maybe if, the way we have been saying, let's say if we can say if
before you do it that way,
yes.
Sorry for disturbing, just undo. Undo.
I wanted to say maybe we can still use we were dealing with low and high. So we can still say maybe if low is greater than high, you return nothing. Then now you go ahead and calculate the mid. Okay, let me just I just write what I had written.
Yeah, what you had written, so I understand first of all your code. So you can explain what that means. It should be my list. It was my list.
Yes.
So you are saying that what is that doing?
So basically, this one, it looks, if the length of the list is equal to 0, it means that our list is empty, definitely. Then if it's empty, the function will return false. And then it stops the recursion. Then after it stops the recursion, now we can go ahead and calculate now the mid value. Because that means our anytime it's checking the list and it's getting our length of the list is empty, that means it will go ahead and it goes ahead now, it calls itself recursively because the list at first end not at any point.
My list or underscore my list.
Yeah.
And sorry, so I think I've understood. Can you just maybe complete and then maybe I'll understand it better? Sorry, someone told me that I wait first of all you finish before I.
Okay, no problem. And like the way I was saying, if you don't want to do that, okay, I will use this, but also another person can say their best value can be if low is greater than high, then that means you return nothing. You see? Because there is no at point whereby in a sorted list, low will be greater than high. Is that true?
Yes, true.
Yeah. So I think also here you can say if low is greater than high, return nothing or return false. That means anytime it's going through that list, because if you say if length is equals to 0, that means that list is empty. So the function will return false and stop the recursion. And there is no any point whereby you have a list and it will be empty unless you initialize an empty list.
Oh,
So that becomes our base case.
Linda, so there's no need of typing the two.
Which two?
If low is greater than high, return
false or none. So you can decide to use, yes, you can decide to use that, or you
or
decide
that
to,
one, that's the one we've written.
yes.
Okay.
Or let me use the other one because we are dealing with low and high. Maybe that will make it easier. If so that means that because if you understand low is equals to high, let's say my list is 1, 4, 10, 14, 19. So the low value here is 1. The next high value is 4. There's no point the low value will be greater than 4 because this is an ascending list, because you've said for binary it searches through a list that is sorted, and it's always sorted in ascending order. So definitely this will return false. And if you look this and the thing I'd written before, if I can equate the length of the list is equals to 0 to return false, I think it's the same thing. Because at the end of the day, this will return false because that means there is no, the algorithm will believe that there is no, the value in the list is false. It's not, how can I say it? I'm even more confused. But this also works the same as the first one that I've talked about. Because there is no any point that low will be greater than. And if the list gets this, then that means the recursion will stop. So this is our base.
Also in this recursion.
Yes?
You'll excuse me, there's something that has come up I need to address, but I'm recording. It's continuing to record, but I'm not present. There's something that I want to address.
Okay.
But
Yeah,
let
okay.
us, you guys continue. Just know it is still recording.
Okay.
Also, Linda, maybe you can define the low, the high, and the midpoint because we need them in this recursive method. Simple.
Yes. So if you get this one is not, so the recursion stops. Or else, if it doesn't stop, now you go and bring in now that the else. So you bring in the way now we have been doing. We were doing low, now you calculate the mid. Who up to there who is not understanding? Okay, so after we've done this, we were coming and saying, if after we calculated mid, then you get the target. What did I do? Else should be like this. Mid. That one is okay. So if you get the target is equals to the mid, right? So if you get the target is equals to the mid, then that means it's true. Then if not, now you go ahead and check if it's greater or equals to 0. See there, everybody is there.
Yes.
Why are we not using else if?
Pardon?
Why are we not using else if?
See, we've said if, or you're saying if I'm not using L if.
Yes, yes.
Because if this one is if this else, then you start another, I don't know if I'm understanding it, but you see, you can say if because this one is like, if low is greater or equals to high, return false, then else, if this one works, the recursion stops. Else, now you go and calculate the mid of the list, then now look if, you can say else if here, because you see else cannot be followed by if I'm not wrong. If is the only one that is followed with if. Right?
Like in short, that is a different conditional than compared to the first one. So you can't use any if. It's not the same conditional that you're continuing with.
Yes.
Okay.
I think also, Linda, you can create some space between the two different.
This one and this one. Yeah. I just want us to reason together because so that we are on the same page. So that means after you've calculated the mid is low plus I, and then you divide it by 2, and then you get it's equal, that if you get the target is equals to the mid, what do you do? You print, you return
Mid.
yes. Or you can return it's true. True. Yeah. Then now you go, the person now was saying if now comes in. So what's next? If our target is less than the mid, what will it do? So if you are doing it iteratively, you could have just say, if target is less than mid, you are saying if it's less than mid, that means you add the low value plus 1, so the mid plus 1. So low is equals to mid plus 1. But here now the difference that comes in is that you will call this function recursively. Like you'll have to call it recursively so that it calls itself, it calls them. It doesn't iterate one by one. It calls itself recursively. Then if it finds that the number is there, then it prints the number. And if it finds that the number after calling recursively is there, then it will head ahead and print false. Or it will print not found, or it will print maybe empty, not there. So do you remember when we were doing Fibonacci, after we did if it's less or equals to this, or if this, then this. If it's not this, then you go ahead and now carry out the Fibonacci so that the sequence goes on and on, because it's calling itself recursively. So here you can return. I'll check the return. Then we call now the function recursively. This function search
By search. Recurse.
Now we call it recursively. So this means that it comes and looks at my list. It goes through the list. Then it looks at the target. You see. Then it will look at the mid and the low. So if it's less than, it means the mid will be plus 1. Then comma high, because it will be going towards high. You see, it will check mid plus 1, then it goes towards high. Else, if it will be target is greater than mid, it will be my list, target, then low, then mid minus 1, I mean, because you are moving from low. Let's say maybe you got this one is low. Then you got that the target is greater than mid. If it's greater than mid, maybe it was, let's say it was here just for example. Then that means that you'll go from, it will check my list, then it checks the target, then mid minus 1. But where is it moving towards? It moving towards the low. the lower side, this side. But because the target is less than the mid, this means it's looking at my list, then it's looking at the target. Then because it is here and it's less, it's moving to the highest because we were calling this high and we were calling this low. So mid plus 1 then high. Up to there.
But since we don't know what we want, are we supposed to type both the returns there, or we just type
You
one
can say
return?
else, it's not a must. If you can say return by recast my list, and then you say else. Is it else?
Yes, else. Then mid minus 1 plus low.
I always have problems with indentations, but it will work.
You're not the only one who struggles.
Yeah. So else, return. What will it return?
The recast. By
By
such
such recast.
No, you can, if you've said
The same thing,
target
but
is less
now
than mid,
after target is low, then mid minus 1.
yeah, so that will be L if.
It will be L.
Yeah, because it's L if it's if, then
Okay, I don't know those ones.
okay. The reasoning I was saying is that let's say, for example, return by search recast my list target mid plus 1 high. You don't have to say else return this and this. So you can just say because if it comes and checks this condition is not right, then it means the other one is it's false. Yeah, that's what I was meaning instead of repeating yourself. So the other one you can just say return false. You don't have maybe to repeat it and say the second recursion. But if there's need be, you can do it.
So okay, Linda, what you mean is that if it finds that the by search recast is not true, it can return false. Or if you don't want to do that, you can tell it to continue with the recursion again to find another number. Or so you can either terminate or continue again with recursive that thing. I don't even know what it is. That recursive thingy.
Recursion, yes.
Okay, so.
Anyone who is lost before we continue? Or if you are
I'm still struggling to understand this return.
Yes.
Maybe you can explain.
Maybe Linda type the other one. Just type the other one, then you explain both of them. I think that will make it. No, don't. Just delete the false. Just delete the false down there.
This one.
Then you say return. Just the word false only. Then return by search recast. Then my list, then the target, then low, then mid minus 1.
Yes, that is how it's supposed to be.
Okay, now you can now explain to Lorraine.
What had she asked?
This command.
Okay. Yes.
This the return bit.
Yes.
I have not understood.
Yeah. So you see, let's say at first we were because we want to know. See, after we calculated it practically, and then we realized that if you have calculated the mid, and then you realize that the mid is not equals to target. Yeah, it's equals to target. I think here we need to have 2 equals. It's equals to target, and then we return the mid because it means the search is successful, right? Then, if you realize that the target is less than mid, what were we doing without looking at the recursive? You remember when we realized that the target is less than the mid, we were moving the right side.
Yeah.
Then we moved the ith, and then we moved towards high. So that is what is happening here. So for recursive, because this function is calling itself, it will go and check the list, then it checks the target that you're looking for. Then, if it realizes that the target value is less than the mid, it moves one step ahead. So mid plus 1, then it ends to high because the high is our latest index value. And if it realizes that the target is greater than the mid, it goes to my least target, then low first, because you see you'll pass first low, and then you start now going reverse. You see where my cursor is moving? You start going this side, and you start going this side, you realize the index, when you go this side, this is the side that we initialized with low, because that was the first index of our list. Yeah.
Okay.
Any other person?
Question. Sorry, I think I was away for a while, but just a part over there.
Yes.
So when we are returning this function, the by search recurse, and then inside we have my list and the target as a whatever arguments or parameters. I'm not really sure which is which.
Yes.
When we add mid plus 1 and high,
yes,
doesn't that affect what we had defined earlier? I'm not sure, because honestly I was away and I'm not sure whether you explained that part.
That if we do what?
You see the function that we defined by search recurse has 2 arguments.
This one.
Yes. It has my list and target.
Yes.
But now when we are coming to return, I know we are not really... Oh, return does not affect calling. Is return and calling the function? I'm wondering, because we have added mid plus 1 and high.
Actually, she can add them to that define so that it can be defined.
Okay, because I'm wondering if we add more parameters than we had defined, then I don't know.
I don't know why
Linda.
Whether it will be an issue or what is it. I'm saying when we defined the function, we had 2 parameters, my list and target.
So my list and target.
But now when we are coming to the return bit, we have 4 arguments. We have my list, target, mid plus 1, and high.
Because you see it's calling. So this okay, you can explain. Just go ahead.
What she's saying, just add, like define it to have 4 of them so that it can show us we are doing the recursive, like upper. Okay,
I add here on this function.
Yes.
No, you can't add here. No, you can't add here. Let me explain to you.
If you run it, it will be an issue.
Let me explain to you something. Just a minute. Let me explain to you something. This is the function you've defined with my list and target. This function here, recursion, it's calling itself. So that means it's calling don't you see it's repeating to call my list and target again? That is the meaning of recursion. We are calling, it's calling itself. It's doing it recursively. So it's going back, it calls itself my list, my target. Then it makes sure it's picking now the index of the number that is needed so that the algorithm can be executed properly. So that means it's going to look at if the target is less than mid, then it adds it moves one step ahead up to the last point. Then if not, if indeed our mid was on the left side, it goes and it calls itself again. That's why you have my list, my target. So you cannot take mid plus 1 and high and bring it to the defined function. No, it cannot be like that. I don't know if somebody's understanding.
Try running it. I tell you what she's saying.
I wanted to check if we have.
My question was actually trying to understand why.
No, before running it.
Yes.
Before running it. Let us remove small errors.
Yes, I think we have
by search recurse. You see the way we have written the word by the first def by search recurse. Write the same spelling on your last return, because not the same like the first one.
Okay, and that's what this one should move to here. Then just a minute. Okay, so which one are you saying? Doing the same line. So this one also should. Yeah. So which one are you saying? Please now go ahead.
The else, the recurse doesn't have an R from your function.
This one?
Hapo. The errors are
Run, then you'll see P's point.
We'll see if it has an error. Yeah, it works.
So, Linda,
Yes?
just stay there. I want like to explain this function and you tell me.
If you are right, okay.
Yeah. So, the function is by such recurse, and you're having two arguments. My list is target.
Yes.
So, if low is high, then we shall return false because there's no way that low can be greater than high.
Yes.
Right?
Yes.
Else, we can now calculate like the midpoint.
Mm-hmm.
Then if you calculate the midpoint and our target is exactly equal to the midpoint, then we return that midpoint value.
Yes.
Else, if the target is less than the midpoint, then we will call the function again.
Exactly.
And then we move like just the way that we're explaining. Now like we leave the halfway.
Yes.
We tunatana now the halfway.
Yes.
If Nigerians were here, kuachana now is leaving it. We leave it. Then we go to the right side.
Yes. Yes.
Else, if
Yes, you are right.
again,
You are right.
okay, else if maybe if now the target is greater than the target is greater than
If it is less than,
then means
if
you are
it is
having
greater than, yes.
Okay, let me explain to you. Let me explain to you like how this recursive is working. So you see, like you've calculated the target, and then you've realized it's equals to mid. You've said that is true, so it will return mid. Else, if it realizes that the target is less than the mid, this means that the target is lower than the list, so it will go to the. If the target is less than mid, it means that it will go to the left. That's true. Are we right?
Yes.
If the target, if we get on the target, let's say our target is 33 and our mid is 22.
Mm-hmm.
So are we going to the right or left?
We have to move to the right.
This should be greater than them, if I'm not wrong.
No.
Okay.
Yes. Because see,
exactly.
Yes, it's right because let me add
Yes, very true. Yeah.
Let's say our target is.
Honestly, I feel like my question was not answered. I think people
Just a minute, just a minute. We'll come back to you. So let's say our target is 3. There is 33, yes? Then you find that our mid value is 24. Right? Or should I interchange so that I say if mid is less than target? So that means that if our target value is greater than our mid, it means we move to the right.
Yes, we move to the right.
Yes, we move to the right. And if it's less, we move to the left. So here it should be greater than.
Yeah.
So
and then I think that is where Pidgey's question is. Why are you having like those 4 arguments?
Okay.
I first understood because this is recursive. We recall that function. That's why you're starting with return.
Yes.
By that, then you take the 2 arguments.
Yes.
And then you add now these 2 arguments.
Okay, let me explain it practically.
That's what I wanted to say. Linda, if you put a code, after this, it will tell you what P is saying.
What?
Just run a code under it, like to say Mesasa, you are trying to implement what you've explained.
Like
if you just try by defining the 2, it will ask you to define others.
Okay.
The ones P is saying.
So that's what you want me to do?
Yes.
Then let's say our target is?
Maybe 9.
9? So we can call the
When you're printing the
we can say result. Okay, we can just call it. We can call the by search, then recurse. So what are we calling? My list. See, that's what we have been doing.
Yeah, my list and my underscore list.
If I'm wrong, you tell me. You can use print, you can use either way. So you're saying that it's bringing?
so run it. Run the first one first. You already ran the first one.
Yeah.
Linda, kindly run that code again. No.
This
You have not run the
Yeah,
other
run
one.
that one. Yeah. Then run the other one.
Then I run
Then
it.
run.
Yeah. I don't know if even if
Not defined. We didn't define what is low, what is high.
So
No, we are not supposed to define it.
Because me, I know when you the way
sasa, that's what P was saying. Haiko kwa hiyo definition. Like hiyo by search recurse my list, comma target inafaa kuwa na comma. Let's say low na comma. That's what
Okay,
she was
sorry.
saying.
Unajua okay, sorry. What I was thinking is, I thought he's saying that you are right. Because it's not defined. Yeah, you're very right. I was thinking, she was saying that I add mid plus one and high. Then I add, sorry, PG.
No,
Right. Thank you so much.
we were doing like the way we have to define something at the top before we come to the bottom. Yeah, to call it there. So now when we call it tena hapa chini, do we need to call
I think so.
the low and the high as well?
yeah, like you see, Linda, can you go up a bit?
Yeah, I think we need to call it too. Let me see. Just a minute. No. Here?
Yeah,
We say low, high, and then now we are calling high, low.
Yeah, exactly.
It must be low, high. Low. It's still not. But this code is correct. It doesn't have any problem.
I wonder what we are printing. We had called that, and then what are we printing? Because go to the second code, we are saying by search recurse.
Maybe the problem is here.
Law ni zero.
Yeah, you see, it's saying like name law is not defined. So
law is equals to zero.
Then the other one would be
law is equal to zero.
Huku juu. Hapa.
Yes, you had said we didn't need to say though.
Yeah.
I is length of the list minus 1.
So let's run it. Am I at the right place? No, there is something better.
Did we delete?
Yes?
Linda,
Yes?
if you go to the function set, you see
I
like
think that, where did it go that iterate, that?
Did you delete it by mistake?
Yes. Let me try. Let me undo and see if I'll get it.
I hope we didn't save. So go yeah.
What has happened?
She deleted that the markdown. So we are calling some things that don't actually even exist.
Where?
Maybe just like what if you can't undo?
I'm trying to do that. I'm trying to undo. I don't know, was it on which list? No, it's not that one.
Sebu and Aju. Ebu
I think I've seen it. Did you move it?
Oh my God, what happened?
I'm imagining my own thing.
There's no way you can undo once you have deleted it, right?
Yeah, normally it refuses. This Jupyter thing is. This is why we like VS Code.
I'm telling you. Just a minute.
It's that one, no?
Yeah.
Which is, but now she needs to add high, low is equals to 0.
Yeah,
high
now.
is equals to
Right? So,
Yes.
low is equals to 0. Then, high. I couldn't have written it again. My list.
Where did you find it even? You just undid.
Yeah, I tried undoing the cells. So is that okay?
Nijaribu.
Huh? It's the same.
Try to see. We'll tell you.
But now the second one, she needs, when she's calling it, it needs to be target, then.
So here should be low, or it should be 0. 0, then comma.
No, low is 0.
Just
because you can say 0 because you equated it to 0.
Low, comma, high. Just write the like that. Yes.
It's still not working.
If it refuses, I'll cry now.
Now our problem is it's saying name law is not defined.
Easy.
Let me tell you something, Linda. Try. No, don't remove it. Try putting that law is equals to 0 in the definition.
Here.
After law is equals to 0.
But it's here already.
Just try there, then you remove these things down here. See, nataka to define, acha to define comma.
Should it be in the definition or when we are calling the function? In my head it will be when we are calling it, but okay, let's try this.
So I get rid of this one.
Put the commas first, then you just copy paste that thingy up there in the calling.
Okay.
So copy paste the whole thing, the by search recurse in this by down here.
This. Then I bring it here.
Yes. Machozi.
Yeah, it was. Yeah.
So
it's okay.
When we do our recursive search, it means that we have to declare these things.
Yes.
Yes. Also, when we are calling it, we do the same. We copy paste the same thing so that it works.
Yes. Okay, who's lagging behind?
I wonder though.
Yes.
If we had just said low at the top and high at the top, and then here
yeah, I'm also wondering.
I'm thinking it would still work. Like here we replace with 0, and then the other one we say length my list. That's just my thinking, because I think when we are defining, we don't have to allocate a value, but when we are calling, then we can give it the new value.
Let's try. So that we
let's just try. We might not be able to.
Let's just try.
But let's try.
0. Then high is equals to length my list, then minus 1. So we run, then we call this one, right? So we bring it here. You see? It's
actually what I was saying was,
yes,
was when you come to calling here down below, instead of writing low, you write 0.
Okay.
And instead of writing high, you write length my list.
Yeah, true. So you write?
So you don't even have to write low is equals to 0 and whatever at the top there.
This way. It's bringing in.
Not returning anything?
Yes.
Okay. Okay. Yeah, but
It's saying recursion error because it's skipping. I think let's just stick to the other one.
Okay.
It picks the my list target, low, and then mid -1. Then it goes ahead. So the more you are moving as you go by recursively, the more the space is decreasing, like the space, because the numbers are decreasing as you move towards the target value that you want to get. So that is what you call, like it's calling itself as the space is reducing, it moves. You see, like for let's say also recursively also works in factorial. You see, like you are going factorial 5 like that. So the more it moves, the more it's reducing the time and the space complexity. Yeah, and that's why the person Lauren had asked why I did not talk about the O log n. This is an example of the O logarithm n. So the binary search always has the O logarithm n time complexity. Yeah. So this one falls under O. Is it O log n? This means that the time required for the algorithm to increase is it's logarithmically proportional as the size of the input size. So that means that if the algorithm increases logarithmically, then the size of the input increases to size n. So it means like this. Let's write O, then log n. So this means that if the algorithm increases like in logarithm, like it is increasing logarithmically, like the way you're saying, maybe increasing directly or increases proportionally. So this one increases logarithmically, then it means that the size of the n also increases. Yeah. So this is an example. This binary search is an example of the logarithm time complexity, big O notation.
It goes back again, it compares whether low is greater than high or something like that, and it goes again.
Yes.
What? Okay.
So you see, like here, for example, the target is less than my list, then the mid value. So that means it will go and call itself. You see, it's going again. It's calling itself recursively. So it's going by search recurse, and then it's calling the list, the target. But this time round, because the target is less than the mid, that means we'll move to the left. You see, so it will be low, then mid -1, or it can be mid -1, then low, whichever. So that is what it does. And the trick here is that the space is reducing, because let's say, for example, if you had 1, 4, 10, then you realize the mid is here. Then you realize that the target is it less or equal to, or let's just say you're moving to the left. Don't you see now you are remaining with only 2? It will just do 2 recursions, like it will check at 4 and check and 1 and return if it's there or not. Like it calls recursively, and the more it's calling recursively, the more the space is reducing. And how do you know the space is reducing? Because you are moving, like after a year, when you realize that you are maybe less or equal to the list, you are moving mid +1. It means you are moving from the I to I +1. So the numbers between the low and high becomes small, like the space becomes small. So the time of complexity reduces. So that is what it means, recursion. So it calls itself as the space reduces. It calls itself as the space reduces until it gets now to that number. Yeah. I think at night we'll do with an example of factorials. you'll see how it will work. Like factorial, it's also we can do binary search recursively on a factorial, then we'll see how it will work. Yeah.
Linda, mention how that time complexity works.
Like how I've been saying.
Yeah.
Okay. So the goal here is that you have your list. Let's say the list is 1, 2. Let me just write it so that 6, 7, 9, 10. Then this function goes. The recursion goes and realizes that we realize that after finding the mid is not equals to the target. We realize that we have to move ahead and check if it's less or equals to, and check if it's less or equals to the what, and check if it's less or equals to the mid. If you get that, the target value is less than that mid, than the element at the midpoint. It means that the target must be in the lower side. See, that is true. Are we getting each other?
Yes.
Yes, that means that we have to go to the lower half of our list. So this means that this recursive function will then call itself with the same list that we had, then with the same target value, but this time around, the search space will reduce from mid to mid minus 1. So let's say, for example, our mid was 6. See, the next value means we'll just check 1, 2, and 4. Don't you see that the time for checking between 3 elements is smaller than if it could have checked through the entire element or the entire list? I mean, not element, the entire list. So the recursive, like, it's reducing the research space. The research space from low to mid minus 1. And again, when you get it's not 4, the 4 goes ahead, you move to 1, 2. It has reduced the search space. So the time that will take the algorithm or you to get to that target value, if it's 1, it will be easier. And like if you had 5, 6, 7, for you to move on the lower half, and reach to 1, it will take so much space. So the recursive is reduces it calls its function as the space is reducing, it's reducing until it gets now to the target value, let's say 1, then it returns now that value that is there. The opposite. Also, if it's on the high value, let's say it was 6, if you go to 7, it gets not 7. The next time it will not carry out recursion on that 7. It will move to 9, so it will only check 9 and 10. If it gets 9 is not there, and you want the 10, it will go ahead and move to 10. So you see that search space from low to mid minus 1, or from high to mid plus 1. The space, the more you go on recursively, the more that space is reducing, and therefore the time complexity becomes lower as compared to if you could have done it maybe with linear search. Yeah.
You had discussed iterative.
Yes.
Okay, I'll just watch back. Totally.
Has everyone understood? We go and rest. Okay.
Linda,
Yes?
you can also share the notebook.
This one?
Yeah.
Okay. Should I download it as a PDF? How do you want it? As a Python or PDF?
Just share it as a nini.
Notebook.
As a notebook. Yeah.
Okay.
Yeah, and then guys, also maybe to test this thing, I think maybe next week or whichever day, we'll try to generate some big data with NumPy, and then I will try to compare these algorithms. For example, when you are trying to compare the search on a linear algorithm or on the binary search or with the recursion, we shall try to generate our random big data, and then I compare the speed. You can, whenever you have values like less than 100, it doesn't have a big difference. But I think this thing will try to show you in in real time. We have a module that can help us to check on time on which the operation has completed. We shall try that, I think, next week, so that you can understand these things very well. Yeah. So I stopped the recording, right?